Hello, everyone, and welcome to the 2023 version of the CDK Day. We're very happy that you're all here to join us because we have like a full day of very awesome sessions. Before we start with that, I have some announcements to make. First of all, I want to thank AWS and the Western Interpreting Network for the interpreting they have today so that everybody can follow along, even if you can't actually hear me. I also want to thank our other sponsor, HashiCorp. They are sponsoring this day as well. Some few other announcements. We have a code of conduct. You can find that at cdkday.com/coc. And we also have chat available. So if you want to join in the chat this year, we have three dedicated Slack channels in the cdk.dev Slack. If you're not there yet, you can join at cdk.dev. And the channels are CDK Day Track 1, CDK Day Track 2, and CDK Day Track 3, which will be the Spanish track this year. And you're watching CDK Day Track 2 right now. So if you want to join in the conversation, you can put something there. With that being said, we can almost immediately jump to our first speaker. Our first speaker today is Masashi Tomooka, and he will talk about deploying web frontend apps with CDK. So very happy to welcome you, Masashi. Welcome to the CDK Day.
Yeah, thank you for introducing me. Can you see my screen?
Yes, your screen is here, so you're ready to go. Good luck, and looking forward to hear what you have to say.
Okay, thank you. So I'm talking about deploying web front-end applications with AWS CDK. And we want, despite what the title may imply, this talk does not intend it only for front-end developers, but also for all the CDK developers, because the discussion goes from front-end to the internal of the CDK. So please stay tuned in this track. So hopefully you can get takeaways from this talk and use the learnings in your own CDK project. But before going into the main topic, please let me introduce myself briefly. So I'm Masashi Tomooka, and I'm working as a prototyping engineer at AWS Japan, but I'm actually currently on parental leave, so I'm joining this event as an independent amateur babysitter, by the way. So prototyping engineer is a role to help customers to adopt AWS, even though they are not skilled at it. So we help customers by developing prototypes of their system on behalf of them. The point is that we've been using CDK very intensively, so most of the time to develop these prototypes. So this talk is also based on the experiences from those prototyping work. So I'm also a hobby contributor to CDK. Recently, mostly messing with the CDK hot swap feature. I like hot swap feature very much. And I also recently released a tool called AWS CDK Translator. So please forgive me to advertise this tool because this is, I think, a really good opportunity to do that. So this tool is to translate TypeScript CDK code to other languages such as Python, Java, C#, or Go. So I published a web. I made this tool because sometimes I'm forced to use other languages than TypeScript because of customers' requirement. And I'm really struggling to catch up with new languages to write CDK code every time. Maybe it's a niche demand, but I hope this tool will help someone like me. You can try this tool from the URL here if you are interested, and the feedback is always welcome. So please try this. Also, I'm today's one of two speakers from Japan. The other one is Hashimoto-san, also speaking now in track 1, by the way. So I'd like to share some status of CDK in Japan. Actually, AWS CDK is super popular in Japan. We have a strong community called Japan AWS User Group, CDK branch. And we are holding a meetup both virtually and physically on monthly basis. And every meetup has more than 150 attendees on average. That's awesome. And we are in the meetup, we are sharing best practices, deep dive into CDK internals, or lessons learned from production use cases. Unfortunately, those events are only in Japanese, but you can find the recordings on YouTube, and they have, I think, machine translated subtitles. So if you are interested, please check those recordings. Also, it's really interesting. So sorry for the long introduction. Now I get into the main topic, how to deploy a web frontend application with the CDK. So let me first define the actual problem I'd like to discuss in this slide. So maybe I should mention first that in this talk, I'll focus on a single page application or a client-side rendering part of frontend. Because deploying application with server-side rendering or a multi-page application is totally a different problem, and it's difficult to cover both topics in this short lightning talk. So what we want to deploy in this slide is the system like in the architecture diagram. We have CloudFront S3 bucket, and in the bucket, we have some front-end static assets like HTML, CSS, or JavaScript. And from the JavaScript front-end client, some AWS resources such as Cognitive User Pool called directory to enable features like authentication. I'd say most of the part of deploying this system is relatively straightforward. You can deploy, for example, CloudFront distribution or S3 bucket, Cognitive User Pool, relatively easily by just using CDK. So the problem I want to focus today is this front-end static assets part. There are actually several ways to build and deploy these front-end assets. So how we can do that? But let me also introduce an important concept of CDK, deploy time values. Those are attributes whose actual values are only available on CloudFormation deployment time, not on CDK synthesis time. Actually, most values that can be accessed with construct properties are deploy time values. For example, cognitive user pool, or in this code, app runner service arm. And with deploy time values, you cannot access directly on the synthesis time. For example, using Node.js string split function, it doesn't work because the values are encoded as a token. A token is a string like this. There are token bracket, 1, 2, 3, 4 bracket. It's a token. So you cannot use those values directly on synthesis time. So this is why you have to use CloudFormation intrinsic functions to interact with the values, because those functions work on CloudFormation deployment time. So they can access the actual value on the deploy time values. So this is an important constraint to think about building front-end assets. So I'll explain more details in the next slides. And to use AWS resources directly from your front-end code, such as cognitive user pool authentication, you need to pass AWS resource attributes, such as cognitive user pool ID, to front-end clients. So in this code example, we pass AWS region, user pool ID, or user pool web client ID to the amplify constructor to enable the auth feature. And usually those attributes are injected during front-end build process. Like this code, we use environment variables on build environment. But as I introduced the deploy time value concept, they are now deploy time values. So these values are not always available when building front-end assets. So the problem here is how to make these values available to your front-end client. So fortunately, there are several solutions to the problem, and I'd like to discuss the 3 patterns to achieve to resolve the problem. So the first one, I think, is the most straightforward, and most of you are maybe already using patterns like this. So in this pattern, you first deploy the backend stack, and in the backend stack, you deploy the cognitive user pool or backend API that is dependent to the front end, and then get the attributes required for front end from those deployed stack outputs, and and pass those values to your front end building environment. So this way, you don't have to care the deploy time value constraint because they are available outside of CDK context, for example, using .m files. So let me actually show you the code to do this here. So this is a backend stack code. You deploy user pool and user pool client. And after you deploy the stack, you get the actual values of these user pool ID and user pool client ID. So using these values, for example, we can use .m file to to pass those environment variables to the front-end build context, and then build the front-end static files, and finally deploy those files to the S3 bucket. So the final output is like this. You can just access the front end and use the calling feature. So again, this solution is good in that it's very straightforward and really easy to understand. It has lower cognitive load. But however, the disadvantage is that deployment steps are a bit complicated. They require multiple steps to deploy the entire system. For example, first deploy backend, and then build the front end, and then finally deploy the front end stack. So it's sometimes a human error prone, and it is especially become problem when setting up a new environment. So imagine you add a .m file and set up the total configuration for a new development environment. Because of all this, sometimes our team is not satisfied with this solution. We want to deploy the entire system in a single CDK deploy command as simple as possible, so that there is no room for human errors, and everyone, or literally everyone, can deploy it 100% successfully. So here comes the other two solutions to mitigate the problem of the first pattern. The second one is to fetch AWS resources attributes on runtime without injecting those variables on front-end build time. So you create some JSON file containing those AWS resource attributes, such as cognitive user pool ID, and fetch the JSON file on runtime. I think demo is worse than thousands of words, so let me switch the screen again. So this is the code of pattern 2, and we are deploying, we are using a feature of bucket deployment construct to create a file containing deploy time values in the S3 bucket. Here we are creating AWS config JSON and it contains deploy time values, and the file is created on deploy time and uploaded to S3 on deploy time, and we can finally load and fetch the JSON file on front-end runtime. The code for front-end is also here. We fetch the AWS config JSON on runtime and use the values to initialize amplify constructor. So here is the actual running the front end of pattern 2. And you can see here this request. You can see the front end fetch the AWS-config.json on runtime. It includes the required information to use the cognitive feature. Okay, so returning to the slide. So thanks to the bucket deployment construct, you can now deploy the entire system in a single step, because now you can build front-end assets independent of backend resources. So actually, you don't need to know the actual value of environment variables when build time. However, as you can see, if you use this pattern, you need to set up the front end very specific to this mechanism, such as fetching the config.json on the first page load. So it means you have to manage more code, and in the performance-wise, it's not very ideal because of it can result in slower initial page load. So this is a pattern 2. And finally, the last one is to build front-end assets, not locally, but on deployment time. It's actually possible to run code build job during a CloudFormation deployment by using a custom resource. And on deployment time, you can freely access the value for deploy time values. So it's relatively easy to pass. It's totally possible to pass these values to the front-end building environment. So let me also show you a demo. And here is the code for third pattern. We are using a construct called Node.js build, which I published last year. And this construct allows you to run a code build job very easily during the CloudFormation deployment. And you can pass the deploy time value as a build environment variables here. And when you run CloudFormation deployment, a code build job is invoked by a custom resource. And the deployment value finally landed here. You can use these variables to when you build the front end inside this code build job. The final artifact will be much same as pattern 1. You don't have to fetch the runtime config.json as pattern 2. So it's also ideal for performance-wise. So, okay, so back to the slide. So the advantage of this solution is, again, similar to pattern 2, we can deploy the entire system in a single CDK deploy command. It's very easy and free from human errors. But there are, of course, some disadvantages also for this pattern. First, the CloudFormation deployment can be more fragile because if the front-end build fails, then CloudFormation deployment also fails. So you may want to check if the front-end build successes before actually deploying them. Also, because you need to run code build job during CloudFormation deployment, there are increased complexity in your infrastructure. But the complexity of infrastructure can be effectively reduced thanks to the abstraction by a CDK constructor library, which I released here, deploy time build. So you can just install this package and it's easily introduced to your system. Actually, it's seeing increasing adoption recently around my team because it's really easy to use and it's free from specific front-end implementation. You can try it if you are interested. So here is a summary for the 3 patterns I introduced. As always, there is no perfect method, and each one has pros and cons. You can carefully compare them and choose the optimal one for your specific use case. Also, there are other possible options, which I omitted today because they are more minor ones, I think. For example, you can use Amplify hosting from CDK, or in serverless stack, somewhat interesting approach is achieved in their construct. So it allows you to build front-end assets locally, but also inject environment variables on deployment time. It's somewhat similar to the deploy time substitution of bucket deployment construct, but more, I'd say it's more optimized for front-end build. As far as I know, the SSD construct cannot be used directly in vanilla CDK, so it's not really available, I think. But it's definitely worth taking a look. If you are interested in this, I also recommend take a look at this. Okay, so I'm now closing my talk. Hopefully this slide helps you to improve your CDK usage. And as I shown, there are sometimes more than one solution to achieve something in CDK. Even for a simple static front-end deployment problem, there are several possible patterns to consider. And optimal paths may vary with your use cases. So carefully compare the options and evaluate the trade-offs, and you'll be maybe better using the CDK in more effective way. So I think it's also a good example to show the benefit to dive deep into the tool you are using. For example, understanding concepts like deploying time value can help you to use CDK more effectively. Okay, that's all I want to tell in this slide. And the code showing demo is available here in GitHub. So if you are interested, please take a look at this. Okay, thank you. So thanks again, and please continue to enjoy CDK Day 2023. Thank you.
Thank you very much, Masai. Like it's I very I liked your presentation a lot. Like I like seeing all the different options there and like the ways to use it. And like we all love links to code, right? And we're immediately going to look at more things because we have our next speaker coming up. Since it's CDK Day, we'd like to talk about everything that's CDK and CDK related. We'll have Momo Kornher here. We will talk about some Projen things, which is always interesting to hear about, of course. So we'll see him appear in a moment here and then get a screen.
Hello, my name is Momo Kornher, and I'm a software development engineer on the AWS CDK team. Over the last year and a half, I have been stewarding the development of Projen. In this talk, I'm going to show you some of the new features that have been added to Projen during this time. To give you a quick reminder what Projen is. Projen is a framework and toolkit for configuration as code. It takes the same principles that you know and love from infrastructure as code and the AWS CDK and applies them to project configuration. So instead of manually creating and managing all these config and setup and workflow files, with Projen, you only need to write a few lines of code. Then run the Projen command and all required files are generated for you. And just like with the CDK, you will automatically get new features and bug fixes in your project when you update the Projen library. But because you are using a general purpose programming interface, you really can do anything. For example, you could read an API model from somewhere and generate a client interface for it. Or do some image processing, which is what you see on the slide here. I've created a project logo design system as a Projen component, and now I can use it in all of my side projects. I just need to define a couple of colors and an SVG icon, in this case those curly braces, and the component does the rest for me. It combines everything together and generates a bunch of image files ready for me to use. If you are interested in a more detailed introduction, please visit our website or watch the Projen launch announcement video from CDK Day 2020. The links are on the slide and probably somewhere in the comments. Since the last CDK Day in May 2022, many new features and bug fixes have made it into Projen. That's over 100 thumbs ups resolved and 17 new minor versions released. But what I'm most excited about is that almost 2/3 of all contributions are coming from the community. Let's dive right in with the most upvoted feature requests we had on Projen so far. Previously, Projen's task runner could only run tasks exactly as they were defined. That works alright if you have defined them yourself. But more often than not, you will be using tasks coming from components. And these really did lack some flexibility. But the good news is Projen now supports passing in arguments to tasks. For example, you can now invoke the test command with the name of the test file that you want to run. Or when you are deploying a CDK application, you can now specify which stack you want to deploy. We have already added support for this new feature to a few components, but if you find one that is still missing it, please open an issue. To use this feature in your own projects, you need to specify the new receive args option on your task definition. By default, any passed-in arguments will be appended at the end of the command. But you can also use the special marker $@ to define where exactly the argument should go. This way they can appear, for example, in the middle of a command that prints a nice hello message. The first interaction many users have with Projen is the Projen new command to generate a new project. If you are only using built-in project types, you probably didn't have many issues. However, Projen's power really comes to shine when you are building your own abstractions and use custom, purpose-built project types. On the slide here, you can see the anatomy of a command you would run to create a project from such a custom project type. It starts with the Projen binary. This could also be npx, Projen. Then the new command in yellow to tell the CLI what you want to do. The third part in dark pink here, -- from, is telling Projen to use an external project type. The package is published to a package repository like npm, and then it's literally just the package name you use here. Finally, you tell Projen the ID of the project type you would like to use. Here, it's a custom TypeScript project. And this can be omitted if there's only one project type available in the package. What's happening in the background is the following. Projen installs the package to the local directory, and it then reads the JSII assembly metadata to find the correct project type, and also to understand which options are needed and what they look like. What didn't work really well in the past is step 3, properly checking the provided arguments. A lot of paper cuts have been removed from this flow. So all required options are now parsed correctly and will print a nice error message if missing. There were some enum options that used to fail and are now working. And we also fixed a nasty little bug with the CLI command auto-suggestion. This is normally intended to help you with typos, etc., but it would get overzealous, and instead of allowing me to use a command like you see on the slide, it would just basically say something like, "Did you mean Projen new Java?" Because it knew that that's something that is built in, but it didn't know anything about the external package you wanted to use. All of these issues should be a thing of the past now, and the commands to create built-in projects and external projects now actually share a lot of the code. One of my favorite new CLI features is that you can now run Projen from any subdirectory. Before, you needed to be at the top level of your project to run Projen, which was mostly fine. But for example, if you have a monorepo and you have to go up and down between the root and the sub-projects, that could get quite annoying. So now the CLI will automatically traverse the directory tree upwards from where you are and find the closest Projen config to use. Speaking of monorepos, Projen comes with a low-level implementation for monorepo-like setups. It pretty much works by telling Projen to generate multiple sub-projects into different subdirectories. But it's not a high-level abstraction, and it can take some effort to get it work well with certain tools. And as you all know, there are a lot of different and opinionated monorepo tools out there. For now, Projen will continue to focus on improving this low-level implementation. And even small changes, like adding this public sub-projects property, can make a big difference. Thanks to Anderson for contributing this change. But it's also great to see that the Projen ecosystem can step in and provide higher level abstractions for monorepos. So today, I want to introduce you to the AWS Project Development Kit. The AWS PDK is built on top of Projen and offers building blocks for common development patterns. It comes with a number of abstractions for websites, APIs, and CDK apps. But it also comes with monorepo project types. They are available for Python, TypeScript, and Java, and if you're interested, the implementation is using NX. On the slide here, you can see the command and code you would need to get started with a new Python monorepo. You should give it a go. At the core of a lot of the functionality Projen offers are GitHub Actions. Naturally, Projen is quite opinionated about the actions and versions it uses for its built-in workflows. With this new feature, you can now inject and set the exact actions that you want to use. For example, pin the version to a commit hash, force the use of a newer or an older version, or even tell Projen to use a patched fork that you maintain yourself. Projen will then replace any matching action with the one that you've specified. We also had a number of contributions to increase the covered API surface for GitHub Actions. Most notably, Projen now supports merge queues and runner groups. GitHub merge queues are a really cool new feature to increase velocity for busy repositories. It's available for organizations only and went GA in July this year. You can enable merge queues as a branch protection rule, and any PRs that are ready for merge will then be put on this merge queue instead of being merged right away. On the queue, the status checks will run again, but this time on the result of the potential merge. And because of how the model works, all PRs can be preemptively checked in parallel, leading to faster merge times. Runner groups are an essential configuration when you are using self-hosted runners for your GitHub Actions workflows. They are typically used to grant specific repos or orgs access to your self-hosted runners. Thanks to the contributors Lex, Rami, and Rumath for these contributions. Projen ships with a built-in continuous release component. This feature automatically releases every new commit to the repo as a new version. It got a big upgrade. You can now specify which commits should be considered releasable and which not. For example, you could decide to only publish features and bug fixes. What happens in the background here is that it looks at the commit history since the last release. Then any commits that are not features or fixes, according to the conventional commit standard, are removed. And if the list of remaining commits is not empty, we have found something to release and will do so. The provided helpers, like the one you just saw, use a variation of the git log command with the correct filtering in place. But the underlying implementation allows you to define all sorts of conditions. It really can be any script that returns a list of commits that should be considered releasable since the last release. Thanks to Ansgar, who created the initial PR for this new feature, which helped shaping the API design. Projen also supports managing multiple versions of a package. If you're not familiar with this feature, it helps maintainers to maintain multiple different version lines at the same time. So, for example, when you publish a breaking change as a new major version, which you should, you don't want the previous version to be abandoned right away. Instead, you want to give your users time to upgrade and still release like security fixes. And that's where the release branches feature comes in. It creates the necessary variations of GitHub Action workflows for each of your active version lines. That way, you can easily keep dependencies up to date and cut releases for all of those versions. This feature used to only support release branches based on major versions, but Julian contributed a change to extend it to minor versions as well. This should give you a lot more flexibility. Next up, dependency management. You could already use Projen or Dependabot or Projen's built-in component to keep your dependencies up to date. And thanks to Juho and Carl, Projen now supports Renovate. Renovate has similar features like Dependabot. But one of the cool things about it is the support for extendable configuration presets. So if you have a lot of repositories to manage, with Renovate, you can create a global base configuration that lives in a single location and use it in all of your repositories. The built-in upgrade dependencies feature got a big improvement itself, with new powerful configuration options. For example, it is now possible to set up multiple different upgrade groups. These groups can upgrade different subsets of packages, run on different schedules, and use different commit messages. So you could set up the two configurations in your project that you see on the slide. The one on the left would upgrade your def and test dependencies. These upgrades would be marked as a chore. You can upgrade them daily, and the resulting PRs can be auto-approved and merged as long as they pass the tests. For your production dependencies, however, you might want to take a more conservative approach. Only upgrade them once a week, always require a human to review the PR, and clearly label them as a feature. Now, using the different semantic commit types for dev and production dependencies is very intentional here, because that way you can leverage the releasable commits feature that I mentioned earlier. So taking this example, the daily dev dependencies upgrade would just be a normal commit to a repo. However, the weekly upgrade of production dependencies would also result in a new release of your package. Good news for our Python users. Thanks to Jeff's contribution, you can now use pipx to run the Projen CLI. Just type pipx run Projen and you're good to go. While you still need to have Node.js installed, you don't have to directly interact with the Node ecosystem anymore. And thanks to Mike's contribution, the creation of new Python projects got easier than ever. After some streamlining of required options and improved error handling, it is now as simple as typing Projen new Python -- poetry to generate a new Python poetry project. Before that, you had to manually disable a bunch of incompatible features, and it was just not a good experience. So thank you, Mike. The Docker Compose component got a number of updates to increase the coverage of supported APIs in Projen. For example, Projen now supports network and entry point definitions. And as you can see on the slide, adding networks is making use of all the flexibility that Projen offers. So instead of being forced to define the network separately and then referencing it from the service, with Projen, you can define the network where it is actually used. That is line 6 on the left here. And you get the correct end result. Thanks to Craig, Eric, and Kenneth for contributing these new features. Many new features for the VS Code component as well. For example, thyt-lab added support for VS Code dev container features. Dev container features are simple and reusable features that are added on top of dev container images. You can use them to quickly add a language or a tool to a dev container without having to create or update a Docker image. This is now supported in Projen, and we have also added extended support for launch configs and new support for workspace files and settings. At its heart, Projen strives to improve the developer experience of managing complex configuration of software projects. So a very special thank you goes out to all contributors that made it easier to use Projen itself. For example, projenrc.ts files are finally the default for TypeScript projects. This used to be a JS file and it was just so annoying. If you want to migrate your existing projenrc.js files to TypeScript, there are some simple step-by-step instructions in the documentation, thanks to Matthew. And thanks to Greg, you can now also use TypeScript-written projenrc files with Python projects, if that is something you would like to do. And last but not least, Tom added support for the JSON patch standard to Projen's low-level object file interface. Patching object files is a great way to customize your project's configuration without having to create a full-fledged component. And Tom's powerful contribution made this a whole lot easier. Let me show you an example. I often find myself in the need of doing some additional things right after a package is published. For example, adding additional tags to npm.js.com. On the slide here, you can see how I use Projen features to achieve that. First, I retrieve the workflow and then the underlying file. By the way, the file property is a convention that most components follow if they are an abstraction on top of a single file. Once I have the file, I can use the new JSON patch feature to append an additional step at the end of the release npm job. This is a very simple example, but it shows nicely how you can use JSON patch and other escape hatches to modify the default Projen configuration. And often it helps you to avoid building complex components yourself. That's all from me. Thank you very much for watching this whirlwind tour of my personal highlights from a very long list of new features and improvements. But most importantly, thank you for being an awesome community, and thank you for all the amazing contributions you have made. Bye!
Thank you, Momo. It was great seeing like all those different features, but also like all those different people that were involved. I really love those call outs. And for people watching right now, as a reminder, we have a chat in the CDK Day track 2 Slack channel, cdk.dev, where Momo is actually hanging out and answering questions. So if you have something you want to ask him, that's a perfect place to do it. That being said, like we have a next speaker coming up, which will be Alex Pulver, who will be talking about CDK and the application design framework. Take it away, Alex.
And thanks for joining. Today, I'm going to talk with you about how application design framework and AWS CDK construct programming model work better together to help maintain alignment between architecture and code. But first, a little context. When I think about product engineering, ideally, I would like it to be as simple as that. I have an idea, and then poof, it makes its way to production, serving customers, and everyone are happy. But in reality, I've seen that's rarely the case. And more often than not, it looks something like this. We suddenly need to learn a lot of different words: application, component, use case, domain-driven design, event storming, flows, repositories. Think about all those things, how they connect, how we decide on them, and how they link together to address the business needs and essentially implementing this idea. And that's where I see a lot of handovers happening and context being lost, which in turn leads to misalignment between business and technology. Now, having worked with customers, I also seen that led to a lot of rework. And I'll give you an example. Let's say a product manager asks the engineering team to implement sign in and sign up page for customers. So engineers say, okay, fine, easy peasy. So we'll just allocate subdomain for each customer, and then we'll use DNS to route those requests to, let's say, dedicated resources for each customer or shared resources. We'll implement our authentication and throttling logic based on this assumption and go do this. Then after a few weeks, they come back and product manager says, oh, I actually needed this to be a unified domain because our customers don't want someone to use, let's say, DNS scraping to see they are using our product. Wow, now they need to rework all that stuff, right? Because that little change in the experience can lead to quite a few changes in the technology. And that's where I see that kind of rework and that misalignment also leading to a difficult to evolve architecture. Because to me, architecture is what connects business and technology. We analyze business needs and we design technology to address those needs. And that's where I came up with the application design framework, which introduces a set of recommendations and a document template to help connect those product engineering steps into a single unified flow with a simple getting started experience. Because I think we already have a lot of information about how to do each of the product engineering steps quite in depth. There are a lot of smart people teaching and doing those things. What I've noticed though is there is really little information about how to integrate those steps together. And I think it's more important to first getting started on a high level with breadth, understanding how everything is connected, and then you can go in depth of each of those steps as much as you want. So before going into more details on this, I want to line on a few definitions with you. So the first one, and I think the most important one, is application boundary. And that's where I really like Martin Fowler's definition of what application boundary is. And it's important that he says that applications are social constructions. So there is a lot of human element involved there, right? About thinking about those boundaries. So one option to think about it is a body of code that developer sees a single unit. Think about Angular application, like it literally says application. Another one is group of functionality that customer sees a single unit. Think about Microsoft Word Online. Like people say that this is a Word application, but it definitely may have more than one let's say, Angular application behind it, right? And it can also be an initiative that those with the money sees a single budget. A little humor always helps. And think SaaS platform. You can think about it as an application, but it probably contains multiple applications of those other types here. So each of those definitions is right and correct simultaneously. It really depends what context are you looking at, I think, and that's really the important notion here. Architecture is how components work together, interact, and communicate. And thanks to Luca Mizzalira, also pointed out important area that Mark Richards and Neil Ford talk about in software architecture, the hard parts, is that architectural characteristics, often known as the entities, are often orthogonal to domain functionality. So if I'll take this prior example, how experience looks like of the domain and sign up and sign in influences how we build security and performance characteristics and other aspects of our application, all those entities, right? So these are related, and we really need to understand how they are influencing each other. And a component, again, I use Martin Fowler's definition for that. Software components are things that are independently replaceable and upgradable. And to me, that's really important for the mindset that I would like us to have in this session. So first one is that application is also an ownership boundary. That's the way I look at this, because things change within an organization. Teams can move, expand, contract, and we may need to move ownership on an application between teams. And that's where we would like to make sure that all application parts and all application components are nicely packaged together, like the pipeline, the wiki page, the environments, access to those environments, such that we can relatively easily to give it to someone else. And also an important notion that application boundary should evolve with organizational and software changes, right? We make the application bigger and bigger and bigger. And at some point, it may be too big to handle for a single team. It's too much of a cognitive load. So we may want to split it into smaller parts. And that's where maintaining also component boundaries really helps. Now, to help essentially connect those things together, I want to walk you through application design framework recommendations, and then give you a little example. So the first step is capture use cases. And that's where I would expect sales, marketing, and product work really close together to understand the problem, to define the problem, and the desired solution for that problem. Then we would like to write stories and flows that I would like product and engineering work together at least at this stage, right? To understand what are the requirements that we need to address or define to implement those stories and flows, first and foremost. Maybe come up with already some kind of architectural draft. Now, what are you really so helping to think through this stage is also drawing some flows, but not technical flows. It's not like, where I do have my load balancer, etc., etc. It's experience flows. And it can be user experience if it's a human-facing system, or it can be system experience, right? If I build some API for banking and so on, I would like to see what is the experience of integrating my API. But that's a bit more technical, of course. Now, after we have those, it's kind of time to formalize requirements. And again, it's a iterative process. We can go further down those stages and then come back up and etc. But these are more or less, I think, the steps we should thinking about, and defining the architecture that addresses those requirements. When we define an architecture, what I highly recommend to do is to again go back to those experience flows that you had, and now again describe them using technology elements. And that's where you get this first alignment, right? You understand how your experience aligns with the architecture you want to build. Again, this sign in, sign up page and routing. And finally, we need to build all of this, right? And that's where AWS CDK comes into play. And that's where I will eventually focus in my talk, how we map architecture to code. So let me walk you through a little example. Let's say I want to build Amazon EC2. And the first use case I want to tackle is to help customers launch instances. Now, of course, within EC2 product, we have other capabilities that we will want to build over time. Let's say Elastic Block Store or EBS to help store data outside of the EC2 instance lifecycle. We may want to build launch templates capability so we can launch more instances faster, and so on. But here I will be focusing just on this one simple use case. The first user story I would like to tackle is, as a developer, I want to launch an instance. And of course, we can have other users, right, wanting to launch an instance, an SRE, a DevOps engineer, and so on. But this is just an example, the first persona I would like to tackle. And that's where I build the experience flow. So as a developer, what is my experience? What's the desired experience I want to have? So I'll probably go to AWS Management Console homepage. From there, I'll navigate to EC2 homepage and click on Instances menu, launch, and maybe fill out some form, and I'm done. So that's the experience. But now I want, assuming I have the requirements already done, right, define that same story and flow on a technical level. Now, when I think about this on a technical level, I realize that I'll probably have some front-end applications and back-end applications. And in this case, I may also need some kind of router, right? Because now I work on instances application, but I also will need EBS. I will need console for EBS volumes, and I also need some backend for handling all those requests coming in from the front end. So here I realize I need to split this up, right? I need to split up instances functionality, and I have a console and the control plane service. Now, I will focus on EC2 console and dive deeper a little bit how the architecture of EC2 instances console application look like. But at this point, I think it's important to note that drawing this flows on technical level can help you validate your application boundaries. And you can use techniques from team topologies, such as thinking about business domain bounded context as a boundary, or maybe regulatory compliance. If you have some PII information or not, you may want to split your applications based on this. Maybe change cadence. If it's a single team and the architecture and the applications will change together, if you think about it, maybe you should put them together. But if you have a different change cadence, you may want to split them up. Or maybe how they communicate, like you see here, right? So this is a very important point to think about the application boundaries. Now, having established that, let's look at the EC2 instances console. So here I have a few top-level components, my toolchain and my service. You can think about source code as a component or not. So my toolchain actually contains the deployment pipeline that will help deliver all the changes to pre-production and production shared environments. But I also have my pull requests built here that will help me to validate merge requests. And I assume I use trunk-based development model and the feature branching. So those kind of the tools I'm going to use. Now, my service has other components. So it has an ingress functionality that allows me to take in the traffic and then pass it on to some compute, which in turn involves my web application. The web application uses some database, let's say, to store session data. I need some network functionality to help all those components communicate, right? And I also need to monitor them. So I have some monitoring component here. Now, here, I think it's really important to use techniques like architectural decision records to capture whatever decisions you took about what those components are, how they communicate, what is the technology that you choose to implement each of those components, and it can be more than one service, right? For ingress, you can use Route 53 and load balancer, elastic load balancing, and other pieces, and more than one resource to do this, right? And this is a lot of decisions to make. I think it's really helpful, especially, let's say, when new people come on board the team, they suddenly ask, oh, why didn't we use that database technology? Does it make sense on the first, like when I think about it? And then you can tell them, oh yeah, sure, we've thought hard about this, go to ADR number 7, and that's why. So it really helps you to evolve your architecture from well-known decision points that are captured. And that's where you can also build proof of concept to play around with those decisions, right? Now, what you see here is that I created like a single source code and a single deployment pipeline, single source code repository, but you can also create more than one source code repository, of course, let's say separate infrastructure code and your runtime code if you want to, or if your tooling kind of pulls you into that. But I really recommend having a single pipeline, a single deployment pipeline per application. I think it's a forcing function to help you also maintain healthy application boundaries, like another dimension, right? Because if your application grows to be too complex and too big, your deployments become slow, your blast radius becomes bigger, and that's where you may want to think to split your application to multiple applications with dedicated pipelines. So I think that's really kind of a good decision point. Now, within those components, I'd also recommend that you organize your resources configuration and business logic together, thinking again about the application boundary evolution, right? Let's say if at some point I want to take out ingress and make it a reusable library, or maybe make it a shared service, it will make it easier for me to carve out all the related code to that piece of functionality. So now let's see how this architecture maps to AWS CDK construct programming model. And first I'll look at the toolchain. So here's my toolchain. And as you can see, it has that same deployment pipeline that you've seen on the diagram with the related AWS resources. And it has my pull request build. It's exactly the same names. Now, what I need to do is also put those resources together in a stack. That's how we deploy them using CDK and CloudFormation. So this stack in this case contains all of those resources, but I could of course do more than one stack if I need to. So that was my toolchain. Let's look at the service now. So here's my service, and it has, let's say, this ingress functionality where I have all my resources, let's say DNS and etc. I have my web app that contains a Docker file and some app.py, let's assume it's some kind of Python web application. And then I have all those other components that are related, grouped under exactly those names as an architectural diagram. And finally, here again, I also need to group them into stacks to deploy them. In this case, I use a single stack to deploy the service, but I can also make the service stack a regular class that would compose together multiple CDK stacks. So hopefully I showed you how you can easily map the different top-level components into CDK code, but we also need to compose them together into the application, the blue line here, right? The EC2 instances console. And here we have those top-level components, like my service and my toolchain, right? And in my app.py, in this case I'm using Python, right? That's where I create instances of those stacks. And I would usually have more than those two. Let's say for toolchain, I would probably have a toolchain sandbox deployment, so I can play around with the pipeline. Plus, I would have a toolchain production deployment that would actually deliver the changes to the shared pre-production and production environments. And I have here like a service stack instance for my sandbox environment, such that every developer could deploy an instance of the service stack as they iterate on changes. Now, if you would like to see an example of application using this approach, you can find it in my GitHub account, Pulver/user management backend. And here I wanted to show you that when you use this approach, tools like CDK Dia or CDK Diagram can actually help you visualize your code and link it back to the architecture as you thought about it on an ongoing basis. So you can see here my application boundary, app boundary. You can see it contains my toolchain, toolchain-production. Then this toolchain has the deployment pipeline, which in turn deploys the service to a production environment. And you can see that looking at my service, it has the database that uses DynamoDB table. And it has a compute that I implement using Lambda function, ingress using API Gateway HTTPI, and so on and so forth. So that really helps me understand what's going on here in terms of functionality and not technology. So hopefully I showed you why application design framework is useful and how application design framework and AWS CDK construct programming model work better together to help maintain a link between architecture and code. Now, with that, I would like to thank you for joining. And if you have any further questions or feedback, feel free to reach out to me on any of those social channels, LinkedIn, X, and GitHub, and have a nice CDK day. Thank you.
Thank you very much, Alex. Very nice seeing all those things there. And like really that thing with the blast radius really hit home with me. So it's nice to see that people thinking about it in like lots of different places. Next up, we have a little bit of a roundtable. So I have some co-hosts that will join me and will actually also like help us during the rest of the day. So Wojtek, Saita, and Andra, welcome to the CDK day and welcome like being on screen.
Hey, thank you.
Hello.
Sorry.
Hi, everybody. I think it would be a good idea to have a short round of introductions, like who we are and where are we joining from today. I also encourage our amazing audience to send out your location and where are you joining today from. So let's start with you, Wojciech.
Hello, everybody. My name is Wojciech Gawroński. I'm located in Poland, so if there are any Polish viewers on this track, let us know in the comments. I currently work at AWS. I'm using CDK since the beginning, I guess. And I'm really enjoying this show already because there's already so many great things to learn and to inspire from each other. So thanks for that.
Amazing. Satya, would you go next from the other side of the world?
Yeah, sure. Hey, I'm Satya. I'm one of the AWS container heroes. I'm also one of the co-authors of the CDK book. If you've read the book, well, yeah, the first few chapters are from me. So that was an interesting experience. I also written another book called Practical Docker with Python. So some shameless plugs there, but I worked hard for those. So Andra mentioned I'm from the other side of the world, which is kind of literally true because I'm based in Sydney, in Australia. And as you can imagine, it's actually 11 p.m. here, so it's quite late. But I've been fascinated with CDK since one of its early days, which also led to how I started writing about a little bit about the CDK. The fact that we could use a programming language to talk about and describe infra as compared to DSS was just a revolutionary thing for me. And now to see it being expanded to Projen and now the PDKs, it's really nice to see that. But yeah, that's from me. I work at the Trade Desk, which is an advertisement bidding platform, as a staff software engineer on site reliability and cloud architecture in general. And that's from me.
Okay,
Ben.
Ben. Yeah,
Awesome.
you started this.
I'm Ben. I'm in Belgium, so back across the world. I work for a company called Clouder. We're an AWS partner, so like we do everything AWS. And like I'm also an AWS hero. I've been doing AWS and switch code and stuff like that for like basically my whole career. I was very lucky to be able to select it to speak on one of the previous CDK days, I think in 2021. So I'm like very happy to like be here again and join this day as well.
Happy to have you. I guess this leaves me. I'm Andra. I'm joining today from Bucharest, Romania. I am now a solutions architect at AWS. This has changed from last year when I was a community builder and joining from the community. I am part of the organizing team for CDK Day, and I'm really happy to be able to help out today and have everybody on, amazing speakers, amazing hosts, amazing interpreters. Thank you very much. Yeah. How do you find CDK Day for now? How do you like it?
I love that we only have seen 3 talks of like the full day, and I love that it was already like going like 3 completely different directions, like all very interesting, but like completely different, not even levels, but like ways of using CDK, integrating with CDK, which I thought was like very interesting to see.
And don't forget, there's also a track 1 going on. So I've been following only track 2 because I'm behind the scenes here. I'm just wondering what sort of amazing content is being shared over there. And I was watching the live chat, and when you have people like Rico coming in and saying, "Oh, that's smart," you know, the talks are going really well.
Yeah.
I see some familiar faces. I see Kenda who's going to be giving a special talk at the end of the event. It's going to be a bit late for me for that, but I'll catch that later once I'm up in the morning tomorrow.
Yeah, so this year we have turned things around, so to say. For the keynote, it's actually the last sessions of today happening on track 1. At the end of every other talk, there will be the keynote. So just amazing talks from the community by then, and then you will have an amazing keynote. Also on this track, you will see most of the talks related to other components of the CDK, like Projen. We will have something about CDKs. There will be some session about CDK for Terraform. So really interesting talks.
And there's a Spanish one this year.
Yeah.
Yeah, that's starting up in about 30 minutes, I think.
So just a few more years and we can do a Dutch one and a French one, and then
Polish and Romanian.
Exactly.
Well, we just need someone to spearhead. So we have Ben who will do the German one. We have Wojtek who will do the Polish one. We have Andra who will do the Romanian one. So
yeah, so we're
expanding across the world.
I see we have Belgium in the audience as well. So we have people from the community who can also help out. That's amazing.
Yeah, I also wanted to give a shout out and a round of thanks to our interpreters who are doing an amazing job. I think we started having ASL interpreters since the first CDK day itself, and we've been having them ever since then. And it's always nice to see comments in live in YouTube chats like that. Thank you for adding them. It makes it more inclusive. And the fun fact about the interpreters is they usually go for like about 20 minutes before it gets a bit too tiring for them. So we try to, that's why you see them being swapped in and off every now and then. So give them, a virtual applause because we are not there in person. But thank you, Sarah, for your hard work, and our next interpreter who's coming in, Ben.
I think another thing that I very much like as a team across the whole day is that just so much things that are not just one person doing something. It's like we saw it in like the Projen thing. Like it's like a lot of different people working together, or like working on an RFP or RFC, and like giving their opinions, finding out like what is actually the way that will work for us, like to use this tool, so we can learn from each other and improve it for everyone.
Yeah, that's amazing. I really enjoyed every talk today, but especially the part where Momo thanked everybody who actively contributed. This is a real show of how great the community is and how we can achieve great things together, actually. So that was really nice.
Yeah, I gave a shout out to Momo in live chat as well, because it was really nice to see people's name being attached to the feature, because usually a lot of is when you have a project like CDK, a project that is being contributed by so many people, whether it is internal, external, a lot of things goes unseen behind release. I mean, you can go to the release notes and see the contributors, but that's not something which a lot of people do. So to see contributors being highlighted in a live stream, that's really amazing. I'm glad to see that.
Yeah, and speaking about this, if you would like to be a contributor, I'm sorry to do this because this is on the other track, but in 1 minute we are having actually a session how to make a first contribution to the CDK. I'm doing this with a broken heart because that means that you will be actually going in the other direction. But at the same time, this is a very important topic. So please join up those.
Yeah.
And I think in general, if you want to participate, like I think I've seen almost all speakers jump into the Slack channel as well. Like asking, like, does anybody has questions? Like, how did you think this was going? So I like really appreciate them, like not only taking the time to make the thing and like present the thing, but also then hanging around and talking about the thing further. Is like very nice to see.
Okay, I think.
Yeah.
Yeah.
So for the next hour, I'm going to be in focus, so no pressure. It's
See you
going to be
next time.
really. See you in a bit, Andra, Wojtek, and Ben. And for the next talk, we have James Eastham, who's going to be talking about build advanced integration patterns. So, and we also have Ben, who's going to coming in and stepping into the interpretation for Sarah. And here we go. We shall start in about a few seconds.
Everyone, and welcome to CDK Day 2023. In this session, you're going to learn how you can codify best practice integration patterns into your CDK code. Integration is a vital part of your modern software systems, even more so if you're building serverless systems. And I'm going to promise you, by the end of this session, you're going to walk away with a programming model that allows you to define a set of constructs that enable you to use the same language, the same integration patterns in your discussions, designs, architectures, and implementation code. How many times have you looked at a piece of code or an architecture diagram and thought, I have absolutely no idea what the person who wrote this intended to do? I'm sure you've also been there when that happens and you realise that that incredibly unhelpful developer or architect was, in fact, you. And that's what you're going to learn over the course of this talk, just how important language is when you're designing and building systems and how you can ensure business people, architects, and your fellow developers can understand exactly what it is you intended to do. And you're going to do that through the lens of application integration and the patterns you have to connect your applications together. But I want to start with a story about the first time I learned a lesson about the importance of integration. A young, naive James was building a serverless solution on AWS, and I had a really simple requirement. I needed to send an email and then mark a record in the database as being successfully sent. Being fully event-driven and asynchronous, I implemented this using two separate services, one focused on managing the database, one focused on just sending emails. And they were communicating over a point-to-point integration channel. Once the email had been sent, an event was published, and the record was then marked as sent in the database. Simple, right? Well, as it turns out, a slight misconfiguration in the response event processing meant that no emails ever got marked as sent, which meant emails keep then getting sent over and over and over again. It took until I had 100 emails in my inbox that I realised there was actually a problem here. The application code, worked absolutely fine. It was the integration what failed. Now that might make you think, who is this James person? And given that he's managed to spam himself, why should I listen to him talking about integration? An old mentor of mine once said to me, it's not the boxes on an architecture diagram that cause issues, it's the lines. And this was an important lesson in just how important it is to be intentional about the integration patterns of your systems. Let's look at why. Why is this so important? And to understand why, let's define what a pattern actually is. The important point here is that a pattern repeats in a predictable manner. Once defined, everywhere you see that pattern, you can guarantee the same behaviour is going to be experienced. Pattern recognition and inductive thinking is a special ability of your brain to not only find patterns, but figure out in a logical way what those patterns suggest about what is going to happen next. The neocortex, the outermost layer of your brain, is what's responsible for your ability to recognize patterns. And patterns are just mental shortcuts that allow your brain to quickly realize what is happening and what is going to happen next. In fact, patterns are not a new idea in software. Published right back in October 1994 was the famous Gang of Four book. It's focused on object-oriented software, but it provides a language around building object-oriented systems. I'm a .NET developer, but if I look at a piece of Java code using the builder pattern, I can pretty safely assume and understand what exactly is going on. Many of the patterns proposed in this book are still widely used in programming today. And importantly, it enabled you as developers to communicate with each other in a common language, regardless of what the language is that you're using. Domain-driven design, published back in 2003, gave you a language and a set of patterns around software architecture and the systems themselves. It allowed you to think about the internals of a given system, how to split that down into different business domains, and then how to design these domains to expose only the necessary functionality. Also published in 2003, which was a fantastic year for software books, I might add, was Enterprise Integration Patterns. And now with a combination of these three books, you have the language and the technical details to talk about all layers of your software stack. Yet somehow, at an integration, at an architecture level, these patterns get lost. You have the language, yet often you skip the pattern and dive straight into the implementation detail. Integration patterns give you a language to talk about how your systems communicate. And when you're building large distributed systems, the number of these communication points grows exponentially. Yeah, I'm sure if you're anything like me, when you're architecting and building systems on AWS, you jump straight into which services you're going to use. Now, the AWS service choice you decide on provides some indication of your intent, but if you're unfamiliar with the service, you have no idea what is going on. You default to talking about SQS or Kafka, SNS or EventBridge, forgetting you have a higher level of communication. There's a couple of benefits to get out of the details and thinking about things through the lens of patterns. I've worked with some excellent engineers in my time building complex systems that solve real business problems. And these systems might be built on premises, running on servers in the cloud, or even fully cloud-native serverless systems. Now, what happens when a new developer joins your team who might not be familiar with your current cloud provider? Talking about a system through the lens of an implementation detail increases that load on new starters to get up to speed. Whereas talking about your system through the lens of patterns at least gives you a common language that all developers can understand and work with. If you imagine you were to join a team and the system was described as using change data capture to publish a notification message onto a point-to-point message channel whenever a piece of data changes, you can understand that. If instead you were told it stores a message in DynamoDB, which then uses DynamoDB streams to trigger a Lambda function which processes the message and publishes it to SQS, unless you're familiar with AWS, you have absolutely no idea what they are talking about. That's just a bunch of acronyms and words you don't really understand. People leave your team, other architects move on. Using a common language helps negate some of them challenges. The other benefit of using patterns is around speed. Technology moves fast. Implementation details change. Thinking in patterns removes that bias from your architecture and lets you use the best service, the best implementation detail based on what exactly is that you need. Now that's a lot of theory. So let's have a look at how you can actually use integration patterns in your architectures. And this is what your typical AWS architecture diagram looks like. Of course, this is CDK day, so many of you are working with AWS and some of these icons are probably familiar to you. But if you think back to early on in your careers or the first time you ever opened the AWS console, you probably didn't know what any of these icons mean. And this also hides a lot of complexity, a lot of your intentions as an architect. How does data get from DynamoDB to SNS? What about the data coming back to Lambda? There's an awful lot of complexity here, and that's potentially just hidden away. And then your language is grounded in services. If you come back to this diagram in 6 months, will you know why you picked SNS over EventBridge, SQS over Kinesis? Now, this is the exact same architecture designed using well-known and understood patterns instead of specific AWS services. Initially, you might think, James, this looks really complicated now. But actually, this complexity has always been there. It's just now been surfaced, and it forces you to think about things more thoroughly. If you distribute a set of requests to some receivers and you need to aggregate the responses back, you need a way to receive the responses. You need a reply channel. You can also look back at this architecture in 6 months and understand exactly what it is you intended. You're using a language now that will outlive any services or business requirements. You could also look at this diagram with little knowledge of the system and understand that a message is coming from a database, it's being filtered, translated, and distributed over a channel to a set of receivers, and then the results are being aggregated back together. The language is simple, it's not lost in acronyms and AWS service names. As an architect, this should always be your starting point, especially if you're building serverless systems. From here, you can then dive into specific implementation details with specific AWS services. Of course, you're still thinking, James, this is really abstract. What does this actually mean when I start building things? And yes, I hear you shout, when I'm actually building things, James, I need to use the specific services. This is too high level for me. But when you're building serverless systems, the line between application code and infrastructure code becomes very blurry. Your choice of SQS versus SNS versus EventBridge is an application decision, not an infrastructure one. So it's only fair that you bring these same patterns into your code. And this, my friends, is the magic of the AWS CDK. Let's now walk through the different components of this architecture and how they can be codified to give you a toolbox of constructs to add this same language to your actual application definition. And you're going to work through this architecture diagram section by section. Take a pattern and look at the specific codified example. In this first scenario, you need some kind of persistence data store, and you need to capture the changes made to your database. You need to implement change data capture. This, of course, guides you to your choice of database. In the CDK, you define a DynamoDB table. Simple enough, right? You configure the properties of DynamoDB, and then enabling change data capture is as simple as enabling DynamoDB streams. Now you have a stream of data coming out of your database. A simple start. So let's take things up a notch. Here you have a slightly more complex integration point. You need to take the message from your data stream and distribute that to a message channel. And during that process, you need to filter and translate that message to be something sensible. The beauty of the CDK is that you can codify exactly this into your code, and using a language with a type system like .NET or Java, you can leverage this to build constructs that codify and validate these patterns. So here's an example of this point-to-point integration channel. And point-to-point integrations are a pattern from the Enterprise Integration Patterns book. The source of your channel is a DynamoDB source, and here you simply pass in your DynamoDB table. The point-to-point messages are coming from DynamoDB. And then you can add a message filter. Here you're adding a filter to your channel. In this case, you're filtering on the type property from the data in your database. In this case, you're looking for a pricing requested message. And then, of course, you need to translate that message to an actual message you can send on to your receivers. You don't want to be sending the structure of your database directly into your message channel, especially if it's the DynamoDB streams format. Notice within this message payload, you're also adding a return address, in this case, an SQS queue. This allows any receivers of this message to have a place to send the responses back to. And finally, you define the target of your point-to-point channel, where you're going to send the messages to. In this case, you're using an SNS target and passing in your SNS topic. Now what you've done is brought a programming model centered in your integration patterns, centered in your architecture, right into your CDK code. It allows you to understand your intentions and implement that using an abstraction away from your AWS services. Under the hood, this deploys an event bridge pipe. If you're not familiar, event bridge pipes allows you to build point-to-point integrations from a range of sources to a range of different targets. You can also optionally add filtering and enrichment. In this case, the filter is added and then a step function express workflow is used for the transformation. You've abstracted away the need to understand Amazon Event Bridge pipes behind a construct that's using a well-known pattern. So let's move on another level now to the scatter-gather, a common requirement to asynchronously make requests to lots of consumers and then collate the results. And starting with the scatter part, you define a scatter-gather construct. And the first thing you do is define the channel that the message is going to be broadcasted on. And you'll notice that this is the same topic that the point-to-point channel was targeting. And in this scenario, you know who your recipients are, so you can define a recipient list. In this case, you have 3 different Lambda functions. Under the hood, this simple construct subscribes your Lambda functions to the SNS topic. But of course, that recipient list could equally be SQS queues or email addresses, HTTP endpoints. And then, of course, you have the gather part. You're using a reply channel and an aggregator, and your aggregator is going to publish an event to a message bus when your aggregation is complete, as well as persisting the data back into your data store. And here's the implementation of your aggregator. Now, there's a lot going on here, I know. But an aggregator is a complex pattern, so let's walk through this step by step. The first thing to do is to define the type of aggregator you're going to use. In this scenario, you're using first best, which means as soon as the first message is received back for a given correlation ID, that's the one that's going to be treated as truthful and the rest are going to be discarded. But this could also be a wait for all aggregator. A wait for all aggregator will wait until every single response has been received before then doing anything else. And usually you'd have some kind of timeout in that kind of aggregator. The first thing an aggregator needs is a response channel to aggregate the responses from. In this case, it's an SQS response channel, and the observant amongst you will notice that this is the same queue that was earlier defined as the return address in the point-to-point message translation. During the aggregation, the data is persisted into a database. You're using the same DynamoDB table here, and the partition key and correlation ID are defined to ensure that the responses that come back are linked to the correct input. And you're also storing additional data from the response in your DynamoDB table. And then finally, the event publishing is defined. In this case, you're publishing a quote completed event, including the correlation ID as part of your message body. And because this is defined as a first best aggregator, as soon as that first message is received, the event will be published to your event bus. A lot going on here, of course, but actually under the hood, this is relatively simple to implement. First, you have the response channel. In this case, the SQS queue is hooked up to a step function workflow, again using an event bridge pipe. That workflow then performs the aggregation logic. And as this is a first best aggregator, a DynamoDB table is first queried to check if any other responses have been received. If there's no other response for that correlation ID, the event is then published to EventBridge. If there's already a response, then the message is simply dropped. If this was instead defined as a wait for all aggregator, the publish to EventBridge would only happen once the records queried matches a predefined number of expected responses. Breathe. That was a lot. So you might now be thinking, so what, James? What does this actually mean for me? Well, you now have a common language across all layers of your stack, from design through to actual implementation, and you have this reusable set of constructs that you can use over and over again. Your architecture is driven by your business requirements, and the code that implements your architecture is a direct reference to the language used. You can codify the best practices. Every single developer now doesn't need to understand how to connect DynamoDB streams to SNS or to aggregate a disparate number of responses back from a set of recipients. You can build all the best practices into a set of constructs that then implement all of these integrations under the hood. And if you think back to the definition of a pattern, something that's repeatable, where the behavior is consistent every time that pattern is seen, you now have that, which inevitably leads to a simplified developer experience. You're now using a common language, and using type-safe languages like .NET or Java or TypeScript allows you to validate at the time the code is written if what's being deployed is actually valid. And that can only be a good thing. If you've liked this content, hit this QR code and you can see all of the code samples. You can even deploy them yourself if you really want to. Of course, they are all written in .NET. Please reach out anytime. My details are there. I'd love to talk about this more. Thank you all for listening and enjoy the rest of CDK Day.
Hey, thanks. Thanks, James, for a super talk about integration patterns and those amazing crisp diagrams and a brilliant code walkthrough. James is hanging around in our CDK Day Slack on the Track 2 channel. If you have any questions, feel free to join in and ask him his questions. And he's also here on YouTube chat. So always we're here to help you out. If you have any questions, just drop them in chat and we will relay it to you. Next up, we have Abhishek Gupta, who's going to be talking about CDK. Before that, we'll give a 2-minute break just so that we can get some much needed hydration break for us, for our interpreters, and for everyone else. So take a sip of water or coffee or whatever it is that you prefer.
Welcome to CDK Day. I hope you have enjoyed the conference so far. My name is Abhishek Gupta. I mainly work on Go, containers, as well as open source data technologies. Feel free to connect with me on LinkedIn and Twitter. Now, some of you can probably relate to this. I certainly can. So just to set the context real quick, working on Kubernetes can sometimes feel like turning into a YAML engineer. And the reason is that YAML is everywhere. It's kind of this lingua franca of the toolset that we use, be it Helm or Customize or GitOps or Kubernetes operators, you name it. But what I'm going to talk to you about today is not about removing or getting rid of YAML completely, because honestly it's not possible. So it's more about circumventing it or pushing it behind the scenes using certain tools or frameworks, and one of them is CDK for Kubernetes. Now, the word CDK for Kubernetes is a bit of a mouthful, so I'm going to refer to it as CDK from now, as it's popularly known. So CDK embraces this infrastructure is code paradigm for Kubernetes applications. So you write code and then use it to use certain tools to convert that code into YAML. Now, I am a Go developer, so that's what I will be showing you today, but there's also support for Python, Java, and JavaScript as far as CDK is concerned. And the great thing is that this is an open source CNCF project, and you can pretty much use it anywhere. It's not specific to AWS or any other cloud provider. Now, CDK is pretty useful to begin with. It's a good first step, but there's always scope for improvement. Now, since it's a low-level API, CDKs can look a bit verbose to begin with, and that's where the CDKs plus library or the set of APIs come in. Now, here is a Go example, but it can change depending on the language that you use. So more than the lines of code or verbosity, I think it's important to consider the level of abstraction. So CDKs Plus provides a higher level of abstraction, which means that in most cases you will have fewer lines of code, an ergonomic API with better defaults, and overall less mental overload. And as developers, we know how that can improve our productivity. And if you're building a complex application on Kubernetes using CDKs, which is perhaps required by many teams across the company, perhaps each with a different configuration. So instead of each developer or engineering team writing their own version of that application, you can externalize it in the form of a custom construct and share it across the company. It's nothing fancy, to be honest with you. It's the same as the concept of using a dependency or an external library, but this is very, very powerful. And the good thing is that there is already something called a constructs hub, which has constructs published by AWS, the community, as well as other providers. Now let's look into a slightly advanced topic. Now you can use CDK's library to represent native Kubernetes objects like a deployment or a service, etc., etc. But in any real world implementation, it's highly likely that you're using custom resource definitions. Now, if you have existing custom resource definitions, how do you manage them as code using CDKs? A good example of a custom resource definition and operators is AWS Controllers for Kubernetes, or ACK in short. With the ACK project, you can manage AWS resources from Kubernetes. Now, this is just an example of an Amazon RDS database, but the same applies for a DynamoDB table or an S3 bucket or an Elastic Cache cluster or even a Lambda function for that matter. And the ACK project has different controllers or operators for specific services. And when you create an ACK resource, the corresponding operators then do what's needed to create and manage that service or resource within AWS. To use any CRD with CDKs, the first step is to run CDKs import by pointing it to the CRD. What this is going to do is auto-generate the required packages with a representation of those CRD objects. Now after that, it's business as usual. You write your applications and you can refer to the auto-generated APIs within your code. Now later on in the demo, I will demonstrate a simple URL shortener application which will be deployed to EKS, and it's going to use DynamoDB as the backend. But the interesting part here is that both the application and DynamoDB and other infrastructure resources are defined using CDKs. All right. Okay. So in addition to being a framework, CDKs also provides a CLI. So I'm going to use the CLI here to bootstrap a very simple application. So let me do that. So I'm going to use this command CDKs init. And I'm going to say, hey, initialize a Go application or bootstrap a Go application for me. So basically I started out with an empty directory and asked CDKs CLI to give me something to work with. And as you can see, CDKs has come back with a simple yet useful starting point from where I can now build stuff. So if I open this main.go file, I can now start defining my Kubernetes object. So let me copy paste some code here just in the interest of time. I'm going to paste some code here for the Kubernetes components that we are going to create. So I'm using a canonical Kubernetes Hello World application here. I have a Kubernetes deployment here with an Nginx container, and I'm using a load balancer type service to expose that deployment externally. So what I'm going to do now is do our favorite thing, convert this into YAML. So for that, I'm going to use the CDK's synth command. So let's do that right away. So as you can see, it has created a folder named dist, and within that it has created our YAML manifest to represent our application. So if I were to open that and go through it real quick, so nothing fancy or surprising over here, to be very honest with you. You have a Kubernetes deployment and a service of type load balancers, just like we had specified in the CDK's code before. So I'm going to now create this, or rather use this YAML. So just FYI, I'm using a local Kubernetes kind cluster here. So I can go ahead and then use the contents of my dist folder. So as you can see, service and deployment have been created. And if I were to quickly search for the pod, it was created rather quickly. So it's in the running state, as well as the service. So pay attention to this load balancers type service, which has been created here for me. So what I can do is to access the Nginx container, I can use port forwarding here. So port forwarding, or you know what, I'm going to need the service name here. So yeah, this is the service name, and I can now, oops, just give me a second, service, and then I'm going to use the service name here, and I'm going to just expose it to port 8080, which is the local port. And if I were to do a simple curl to access our Nginx instance, curl localhost 8080, and as you can see, I'm able to access it. Now, just to make sure, just for you to believe that that I'm indeed using this, if I were to close this kubectl, the port forwarding, I will not be able to access it anymore. So yeah, we were able to set up a simple hello world CDK's application using the bootstrap functionality or CDK's init functionality from the CLI, and then we synthesized or converted that into YAML, and then we used kubectl to create our deployment and load balancer service, and then we access it using our localhost instance. All right, so let's clean this up, and I'm going to show you the second demo now. All right, moving on. Okay, so now I'm going to move on to the other demo where I'm going to demonstrate to you or show you or walk you through the CDK's plus aspect. So the code which you saw earlier in the screenshot in the presentation was a rather simple example, and what you see here though is a WordPress stack. It has a MySQL database and a backend component, and each of those components is defined by its respective chart. So as you can see, I have a chart, a CDK's chart for the MySQL database component, and if I were to scroll down real quick, here is the chart for the WordPress or the actual backend component. Now, I'm not going to explain each and every resource in the interest of time, but what I want to draw your attention towards is the usage of the CDK's plus API. So for example, if you see here, we define a deployment and then we add a container to it. Okay, and then we define a secret from static values over here in this case, and then we add that secret as an environment variable to our container. We define PVCs, persistent volume claims. We define volume names and associate those volumes and volume claims and so on and so forth. So the point I'm trying to get at is you should notice how natural and more intuitive the API, the CDK's plus API is compared to the vanilla CDK's stuff. And you also don't if you notice, you did not need to add any boilerplate things like selectors or labels. It's all kind of taken care of internally behind the scenes. All right, so I'm going to close this and move on to the custom construct part. And to understand custom constructs, I'm going to continue, let me close this. I'm going to continue using the CDKs, or rather the WordPress example, which you just saw. So here, if you see this chart right here, and notice this new WordPress construct function, which encapsulates the process of creating components for a WordPress stack. And notice that it is a construct, it is not a chart. So imagine if someone who wants to stand up a WordPress cluster, they can go in and simply use this custom construct, just like an API, which I have done here, and easily provide configuration for a WordPress installation. Now, if I were to go within this WordPress construct a little bit and show you what's going on. So this is not very different from what you just saw earlier. It's just that I have sort of reworked this a little bit for it to be reusable. Now it's one gigantic sort of method, and this WordPress props struct which you see here, it lets me capture the configuration, which can then be passed on by the calling client or the function, in this case by this chart right here, and I create this WordPress props to configure. And of course, I've this is just for demo. I've given clear text passwords and so on and so forth, but just to show an example. All right, so I can run CDK's synth once again to convert all of this into YAML, and then see how this goes. CDK synth, and now it has converted our components into YAML files. Now let's take a look at that. And again, nothing surprising here. So we have everything which we earlier specified in our CDK's application. So we have a secret for our MySQL deployment. We have the deployment object for our WordPress, and if I were to, and these are all the nitty-gritty and the details which we, like I said, mentioned in the CDK's code itself. Let me talk about the CRDs, or custom resource definition. For that, let me open that respective file, and just to make sure you understand, so what I've done is already imported these CRDs which you see here, using the CDK's import command. So it's a long process. I didn't want to waste too much time doing that. So if I were to open the first CRD here, it's a public URL, as you can see. This is the ACK, the AWS controller for Kubernetes DynamoDB table CRD. As you can notice, this is a custom resource definition, obviously, and this is from the DynamoDB group within the ACK, and this is of the kind table. All right, so like I said, I have already imported this, and there is another CRD which I imported actually, but this is not, you don't need to understand this in the context of CDKs. This is very, very specific to ACK. It's called field export, but I'm not going to talk about it because, again, I'm going to just focus on the CDKs aspects. All right, so like I said, imported CRDs, and let me open the main code here and just scroll up a little bit and show you how I have actually now used those CRDs. So after actually importing this, within the imports folder, if you see, CDK actually created these packages for me. So this is corresponding to DynamoDB, this is corresponding to the field export and some of the other related stuff. And this is what you see being used here in the application itself. So for instance, I'm using this package here, if I were to scroll down, to define a DynamoDB table. Okay, so now, as you might expect, there is a specification for the table. We have the attribute definitions, just like we would for DynamoDB table in general. The table name, obviously, the key schema, and so on and so forth. So this is how these packages which were auto-generated by pointing to the CRD, by the CDK's import command. Okay. So just like before, I can actually run CDK's synth once again. But before I do that, if I were to scroll down a little bit, so you saw the DynamoDB part, but there is also the application part as well. So the application in this case is a very, very simple URL shortener application, like I had mentioned. So we have the deployment and a container, as you might expect, and there is a service as well in this case. All right, so I can run the CDK's synth application, synth command as expected. Oh, this does not have the table name. Actually, I'm using the wrong, yeah, I had a shortcut here. So this generated, as you can see, a couple of files in the dist folder. And if I were to open them, again, no surprises there. Now we defined DynamoDB within our CDK's code using those auto-generated packages, and this is now converted this into YAML. And this is the YAML which ACK, or AWS controller for Kubernetes, in this case the operator for DynamoDB, is now something which it's going to understand and create a DynamoDB table behind the scenes if we were to use this. Now I'm not going to demo that in the interest of time, but as you can see, this has been converted to YAML. And other components as well, like I mentioned, some of the aspects around ACK, the field export, etc. I'm going to ignore that for now, but just focus on the DynamoDB table, which is an ACK resource. And of course, as I mentioned earlier, you're also going to have the deployment along with all the environment variables and so on and so forth, as well as the service, which is ultimately going to help access this application publicly. So that's that in terms of how you can use custom resource definitions with CDKs by importing them in the form of packages and then writing code using those specific APIs, converting them into YAML, and then it's business as usual. Now, moving on to the CDK part, the AWS CDK part, and how you might use it with CDKs. So for that, I'm going to switch over to another folder and quickly walk you through the code here. And like I mentioned before, I'm using both AWS CDK as well as the CDKs library here. So as you can see, for example, in this case, I'm using this AWS CDK to define my DynamoDB table. This is not CDKs like I just showed you before in the previous example. So we are just creating a table along with the table name, the partition key, so on and so forth. I'm using the EKS, the AWS EKS package from AWS CDK to get hold of an existing EKS cluster. I could have created a new one as well to deploy my application and push it to ECR with the help of a single line of code here. I'm using this package called AWS ECR assets, and so on and so forth. So that's the AWS CDK part. But notice the interesting bit here. Now I'm in the CDK's zone. So as you might have seen earlier, I've now specified an app here, and what I've done is used this specific method function called add CDK's chart, which is kind of bridging this gap between CDK's world and the CDK world. So what I'm doing is saying, hey, you know what, deploy or create this chart within my EKS cluster. And this, remember, is a AWS CDK object. And like I said earlier, this is bridging the gap. Now what I'm doing is asking my code here to install this chart. And what is this chart here? If I were to go into this new DynamoDB app chart function, this is what you just saw earlier in terms of the DynamoDB application. So it has a deployment and a container, and it is exposed via service. It is just that now I've encapsulated this in the form of a separate chart. I have externalized some of its configuration aspects, and then finally used it to wrap up a slide full of words. How ironic. But the key takeaway here is that it's not really about removing YAML, or it's mainly about reducing it and embracing the infrastructure is code paradigm using tools such as CDKs with good old regular programming languages that you like, love, and have been using over the course of many years. And I
Hi, welcome back. Thanks, Abhi, for the presentation. Thought it got cut out a bit abruptly. We'll have to figure out whether that was intentional or something went wrong in the recording. But well, it's our 10-minute fun time back. So we have our interpreter Ben, who's back. We have Wojtek. We have Ben Bridts back again from Germany, and we have Andra again coming in from Romania. So welcome back. How's it going so far?
Really nice. Yeah.
So 1 point, I'm in Belgium, not in Germany. I have to defend the home country.
my bad. This is like saying I'm in. It's like saying I'm in Australia, not New Zealand. But
it's very close. It's very close.
Yeah. sorry. My bad. Here's another fun fact. Andra is actually running behind the scenes for the first half. So if you've seen all the transitions between our speakers, between our interpreters, that's Andra who's coordinating it in a very nice, smooth fashion. So big round of applause to her. Yay. Okay.
Almost, thank you.
And Wojtek will be taking over her in a short while. But yes, an interesting thing. Now that CDK is getting more and more popular, and I'm also seeing offshoots like CDK TF, CDK. It's also becoming more and more popular. Have you all used any of these, or is CDK still the primary thing that you use? We'll start with Andra. We'll go in alphabetical order. We'll go with Andra and then Wojtek.
Yeah, sure. So I've only used CDK, plain CDK. I touched a bit of Projen projects, but I really want to get my hands on CDKs. Want to focus more on like containers and deployments of containers, and of course I will choose CDK for building the app. And yeah, I'm looking forward to try it out.
I'll continue the alphabet, right? I think it's very similar here. I work for a consulting company and like a managed services company. So we see a lot of different things, like in the whole infrastructure code space, like both CDK and non-CDK. But currently, from like the CDK part of things, like it has been limited to like the like original flavor. Although we do have some like projects where we're using Terraform, for example. So like CDK TF like might be something that like pops up eventually, something that like will be in our stack.
Wojtek?
On my end, I would second what Andra said. I laid my hands only on CDK at the moment, and also on Projen. So again, I would love to be more involved in the CDK for Terraform and CDK for Kubernetes as well, CDKs. That would be great, but I didn't have time yet.
Personally, I started using just CDK. I've tried to use CDKs, but sorry, not CDKs. I tried to use CDK TF, but this was when CDK TF was just starting off. I think it was barely even alpha, and it was pretty broken at that point. And I didn't want to let an alpha build, influence what I think about a particular project because it's being developed so fast. And I think both CDK-TF and CDKs have a lot of promise, especially with how verbose, or rather how excessively long YAML templates or Helm templates can get. But I'm definitely interested to see how they get along. And one more thing is now, so I've been, for the past few years, I've been using Python quite heavily, so I never looked at the programming language toolsets apart from Python. In the past 1 year, I recently changed my job. So in the past 1 year, we've been using TypeScript quite heavily, and that's also influenced. And part of the reason for TypeScript is because we are using CDK quite a bit. I also want to see how Projen goes along really well with other TypeScript-related projects as well.
Do you find that to be easier to work with if you use TypeScript with CDK versus using Python with it?
I definitely felt that. I don't know about you. I'll let you chime in. But personally, one of my top feedback to the CDK team always has been, I love CDK. I love the way things work, but it's clear that, TypeScript generally was your preferred language, and because of GSII and Rosetta, which are the underlying libraries which generate these bindings of sorts for the other languages. The problem is the documentation often used to be, and I say used to be because now I've completely started using TypeScript, so I don't know how it is now. It used to be very heavy TypeScript oriented.
Yeah, it's interesting feedback, and I think like a good thing to see here as well, like you mentioned, it's like that kind of feedback is something to bring back to the CDK team. Like in general, like everything AWS related, like you should like, well, I'm going to point to the AWS person to like actually explain it, like telling the AWS people what you think of the things and like what would improve your life is like the best way to actually get those improvements later.
Okay. See you later, I think.
Oh yeah, we're just for the next. We're in time for the next stop, and I will let Wojtek take over from me, and off you go.
Thank you, Satya. So I'm extremely interested in the next two talks, actually. First one is about the functional testing. Another one will be about integration testing. And I'm extremely excited because both are important topics, especially for the CDK and for the infrastructure as code. They are also very close to my heart because I love talking and also learning how other people are actually taking care about software quality in the software development lifecycle. So I will be more than happy to see what our speakers prepared for this. So we will start with the Eyal Keren that will talk about functional tests. So let's set the stage and let's pass the voice to Eyal.
Hi, and welcome to I Ain't Mocking, functional tests without any mocks for cloud application. My name is Eyal Keren. I have 4 kids under 8. I live in Tel Aviv, and I'm a former test-driven developer fanatic. You'll see signs for that in this conversation. I'm a chief product officer of Quinn Cloud, and this is my first time talk at CDK Day. So first of all, thank you for hosting me, and I hope you enjoyed this session. What are we going to talk about today? The session is going to be split up to two parts. A short introduction to Wingline toolchain, where we're just going to lay out the basics to what the toolchain I'm using, how it's related to the CDK, and what's unique about it. And the second thing, we're just going to do live coding, and we'll create a simple cloud application. And I'm going to do this test-driven developments first. So writing the tests, seeing them fail, making them pass, and then writing more tests. So what is Wingline? Wingline is an open source programming language designated for the cloud. Now, when I think about programming language, I still think about C. And C is, I can write a C program that opens a file and read it, and then I can decide how do I compile it. I can compile it into an ARM or an AMD computer with Linux, and I'll compile it to Windows with an Intel. So basically, I can compile it to different types of machine. The same program compiled into different type of machine. Winglang is similar in the fact that you can compile Winglang to different type of cloud, not machine. So if C is targeting a computer, Winglang is targeting cloud. What does that mean? It means when I go to Winglang and I do compile, and I can say I want to compile this into Terraform on AWS, or I can compile this to Helm chart on Kubernetes, and I can compile this to AWS CDK. This is the target of the cloud. So that's the first thing that is unique about Wing, is the fact that it compiles into cloud and not to computers. The second thing that is unique about Wing is that it takes the two notions of provisioning or infrastructure. In this case, I'm creating a new S3 bucket, or actually I'm creating a new bucket. When it's going to be compiled to AWS, it's going to be an S3 bucket, this line 3. And the other thing, line 4, also creating a Lambda function. In AWS, it's going to be a Lambda function. But then line 5 is actually code that is application logic. You have the in-flight keyword that indicates that this closure, the function that is running here on line 5, this is code that is actually going to run in the cloud. So we have pre-flight, line 3 and 4, that's going to run during compilation will be compiled into Terraform or AWS CDK or Helm. And we got the other part that is compiled into program language. So let me show this a little bit. So I'm doing win compile -- target tf Terraform -AWS. And there's two different artifacts for this simple application. One of them is, in this example, Terraform assets. So I have the S3 assets and I have all the associated assets for the cloud function. So the Lambda function and the policies and the roles and the attachment. The other side is I have actually JavaScript. So Win compiles into JavaScript in this example. It can compile into Docker files. It compiles into JavaScript. And you can actually see that the b.put file text actually calls us await b.put file text. I mean, it's the same thing. Now, another interesting thing that if we take a look at the IAM policy that was created here by the Winglang toolchain, we can see that I already have a bunch of permissions created. And this is the exact least privilege permissions that cloud.function is required in order to run. So the Lambda, the compiler sees that this cloud function needs to call b.put. When you compile this to AWS, our standard library, the AWS implementation of our standard library, knows that if you're a Lambda function and you need to call b.put, you actually need to ask for those two permissions, the put object and the abort. So that's just a nice supplement of what the Winglang does on top of what I said, just creating the least privilege permission, the IAM roles for you. Another interesting target besides Helm, Kubernetes, Google, and Azure is simulator. What happens when I do win compile -- target simulator? It creates an executable that I can run on my machine that basically mimics the entire cloud. It mimics our standard library, basically. So when I do win compile -- target, I can actually run an executable that will run a console, and there's a nice UI view of my cloud application, and I can also interact with it. I can click on the function and invoke. We're not going to do a lot of this because we're going to do everything test-driven development, but maybe we'll take a look at this. So this is about compiling. The other thing is about testing. So how do I test a Winglang application? So now I have a test here. So let's go over this test. I have I have this function. I'm going to do invoke. I'm not sending any information. And then I'm going to wait until b.exist, that the bucket contains the file text. I'm going to wait for 5 seconds. If after 5 seconds it doesn't exist, the test is going to fail. If it does exist, I'm going to take the content after the file text and I'm going to make sure that the content equals hello.wing. So I'm using a bucket here. I'm using a function here, and I'm writing the test without mocking anything, with just using those objects as like it was in Java, they used to call it plain old object, just POJOs, easy POJOs. And the interesting thing about this is that I can run this, I can do win test -- target sim and run this locally. And this will basically be running on top of the local implementation of a bucket of a function. But if I go and do win test -- target tf AWS, it will basically, if you can see the command line here, it will basically compile this to file into tf AWS, and then it will do Terraform init, Terraform apply. It will set up the test runners, because every one of those tests is actually a Lambda function waiting to be invoked to test your application. And then it will run the test, and eventually it will collect all the results of the test and get it back to your CLI and do Terraform destroy. So you can write the same software and run it in multiple places, but you can also run the same test and run it in multiple places. So now you can have actually guarantees that things are actually working as you intended across all your designated targets. If you want this software, you can run on AWS and on GCP and on Azure, and there's a way to verify, an automatic way to verify that it works. That's it. That's what I want to tell. Now let's code. Okay, great. So this is what I've prepared in advance. So I've done a little bit of importing stuff. So bring is our keywords for importing. So I'm bringing our cloud standard library, utils, and HTTP. I'm going to use them. And then I'm creating two buckets. One I'm going to call origin, and one I'm going to call uppercase. And in order to know what I'm going to write, I'm just going to write a test. So I'm going to do this really test-driven development style. So I'm going to do test when uploading a file to origin, and an uppercase version should be created. Not the best name, pretty long. It will work enough, good enough for us. So how do I do this? I'm going to call origin. I'm going to do put. As you can see, when I click origin dot, I have all the functions that a developer would expect to see, kind of when interacting with a bucket in runtime. So I'm going to do put, and I'm going to call it file, and I'm going to have ABCD here. Now, what do I want to check? I want to check that the uppercase dot get file let actual equal, and I want to do assert that actual equal ABCD. As you can see, this is uppercase. Now, things take time. I need to make sure that I'm not running this test too fast. If I'm just going to run this test right now, even after I'm going to build this, it's just going to fail. So this is why I have the util. I'm going to do util dot wait until. And what I'm going to do here, I'm going to say return. I'm going to wait until the bucket, the uppercase dot exist file. And I'm going to wait for a 5 seconds timeout. Okay, awesome. This is too long. Let's keep it too long. When uploading a file to origin, an uppercase version should be created. And now I can run the test. So I'm going to my terminal. I'm going to wing. Let me make sure that I've saved this. I'm doing wing test, and I'm going to do main.w. Now this will take 5 seconds because the file is not going to, I haven't written any code that will actually implement this. So it took 5 seconds to run this, as you can see. And basically object doesn't exist. So we need to implement this. So implemented this, it's pretty easy because I can just hook on, I can go to the origin and create an onCreate event. And when a file is created on origin, I'm just going to create this file under the same name on the uppercase. So when I go into what we call the pre-flight, this is the in-flight stuff, or what we call the pre-flight, I can see that I have onCreate event, and I'm going to do an in-flight, takes a key or a file name, and I do uppercase dot put. I take the key, and it takes the body. The body here will be, let's do let content, let s equal origin dot get key. Wait, and let's do s dot uppercase. I think my application should work right now. So let me clean this. And it passed. Now, at this point, I know that it works on localhost. I need to trust the SDK in order to, the standard library, to make sure that it works on the cloud. Let's imagine I don't trust it. So I'm going to run this on AWS. And this takes a little bit of time. It takes about a minute because the Terraform init takes time, Terraform apply takes time. It does run multiple. If I would have multiple tests, they would all run in parallel. But this takes a little bit of time. So we'll be able to see the result in a couple of minutes. Let's examine the test again. We got origin.put, we got wait until, timeout, and get in file, and this is ABCD. This is awesome. And I think I have a bug here that I want to test. So I'm going to wait until this finishes, and I'm going to go back to this. But let's write, I think I have a bug here. Updating a file doesn't uppercase the new version. So I think that once I'm updating a file, it doesn't call the uppercase in the new version. So we can test this. So we can copy the exact same code here. Let's call it 1, and let's call it 2. And I want this to be 2. So let's go back here. I think the test has finished. So I'm doing Terraform init, Terraform apply, setting up time, running the test, everything passed, and took 55 seconds. So now I'm writing a new test that actually kind of shows me that I have a bug in the system. So I'm going to do this time. Once I figure out the system is not complete, I'm writing a test and making sure that it fails. So what is the test? I'm creating the same file, and I'm calling it ABCD1 and then ABCD2, and I want to make sure that the content of uppercase is ABCD2. Okay, let's run the test. I'm going to run this locally because I want to make sure that. So I need to save it. Okay, save the file. Whoop. Didn't want to do this. Okay. So now one test passed, one test failed. A file don't uppercase a new version. Let's fix this test. So in order to fix this test, I think that onCreate is not good enough. So I can do onCreate and onUpdate, but you can just do onEvent. This will cover both onCreate and onUpdate. So now when I create a file, it will update, but also when I update the file, it will update. So I should be seeing the test passing, which is awesome. Great. Now let's spice up to our application. And let's imagine that the product, those I'm from the product organization, if you don't remember, so those wonderful people in the product wants a way to see how many files were processed. So let's give, so they want to see this with an API gateway. So let's give the product people a way to actually see what's going on in the API gateway. So let's do this. Let API equal new cloud.api gateway. And let's do a test. Get on analytics should return the number of item item processed. Yeah, processed. There's a typo here. Process. Well, not an English speaker, not a native English speaker. Forgive me about this. Yeah, there's too many things here. Okay, fixed. So what I will do, let's just for the fun of it, let's do api.url. So as you can see, I created a new API gateway here. This will create a new API gateway. And I want to do, let's do http.get. When I'm going to api.url, I have the API URL, and I'm going to analytics, right? Great. I'm going to get a result. Let res equal result. And the first thing I'm going to do, I'm just going to assert that res dot status equal 200. That's the first thing I'm going to do. And this should fail because I haven't created this analytics pass yet, right? I mean, I don't have that at all. So let's see that it fails. Okay, so it failed. 2 passes, 1 failed. Let's go back here and let's implement this. So the first thing I will do api.get. I'm going to do /analytics, and I'm going to give it an insight function. This insight function is the function that's going to run when a request gonna show up for this path. And just to make sure that the test passes, I can just do return status 200. And let's see if it works. It works like a charm. Okay, so now I have it. It's not really what I want to do. I mean, the test is not testing enough. I want to actually test that the body contains the number of items processed. So let's do a body is an optional. So I want to make sure that I have a body. So I'm going to do if let body equal res.body. This syntax basically says if the body is not an optional, if it really exists, so assign it to body. else I want to fail. So body is nil. This is an issue. And now I'm going to do assert body equal 0 because I haven't processed anything. Every test run in isolation. The fact that I've added stuff here doesn't mean that it was processed here. Okay. So let's save this. And this test should fail because I don't have body at all. Great. So it did fail. And now I'm gonna do something that people do in test-driven development. It's kind of weird. I'm just gonna make the test pass in the most idiotic way possible. Let's do this. Okay, it passed. And now, let's change this to 1. So I hard-coded 0, which is pretty awful. Let's change this to 1. So I'm gonna do, before running this, I'm just gonna run this. I'm just gonna basically create a file to make sure that it's processed. And I can do this for 2 files, file 1, file 2, and file 1. I need to make sure that it exists. And then there should be two file processes. So now it's still going to fail because this kind of fake it until you make it doesn't hold anymore. Now I could be writing 2 and then writing 2 tests. I don't need to do this. I basically just need to count how many times I've done this code. Now, how do we count? In programming language, you can use a counter because you can just use an int. But because we are running a distributed system, I can't just use an int. I need to create some kind of an atomic distributed counter. Luckily enough, we have an atomic distributed counter. So let's use it. Now the counter is interesting because until now, API was API gateway, bucket was S3, everybody understood it. The counter actually in AWS creates a DynamoDB instance and use it as a file. So I'm going to basically, every time I call the uppercase, I'm going to increment the counter. And when I return this, I'm going to do, instead of 0, I'm going to do counter.pick. I'm going to figure out what's there. And now every time there's processing, I'm incrementing a counter, just adding 1 into a counter that starts with 0. And I should be seeing 2 here. I don't know. Let's see. Okay, so I've written 3 tests. I'm going to do 2 things right now. I'm going to do wing run, and I'm going to run the simulator. I can compile this to the simulator. Wing run basically runs the simulator, main.w. I probably need to take myself here, so it'll be easier. And now I can actually, in the simulator, I can actually see my application. So we have the origin, the buckets, we have the uppercase bucket, we have the cloud counter, and we have the API gateway. I can go over this API gateway. This is the simulator. We've shown this before. I can run my test here. So if I run update in the file, I'm going to run this test. Now I can look at the uppercase, and I see I have the file, and it has the text here. I can have the origin, I have the file, and the text here. I can go to this place, to the API, and basically ask for analytics, and I get 2. So just to make sure, we're able to basically interact with this. I can go into this file and upload this file here. This is hello 8. And if I go to uppercase, I have hello 8. And if I refresh this thing here, another file was processed. So it's a real application running locally. I can also go to my wing and compile this thing. And actually see the result, and I can actually go and do Terraform, apply, and run this. It's going to be the same result. We can actually verify this with the test, and basically have the same result. So kind of going back to what I've done, I've created tests using cloud primitives that are part of our standard library, and was able to run the test on both localhost and AWS. And I think we're pretty much out of time. So I thank you very much for tuning in. Ping me over the channel and just connect with me over Wingline Slack channel as well. And hope you have fun running tests and writing tests and making sure that they pass. Thank you very much.
Thank you very much. Thank you very much, Eyal. That was very impressive, especially that we've seen test-driven infrastructure as code on the actual presentation. And we actually seen the functional tests. So now it's time to see the integration part of the tests. And our next speakers, Iris, Svenja, and Philip, will actually tell us more about the integrational tests and part of the integration test that we will like to see in practice. So let's set the stage and passing mic to the speakers.
Hello and a warm welcome to everyone out there. My name is Svenja and we're here today to talk about integration testing for AWS CDK. In more detail, we have prepared a demo to show you how you can test your applications using the CDK integration test construct in combination with the integ-runner. Before we start, let's take a look at who we have in the call today. So there is Philip.
Hey everybody, my name is Philip. I'm a senior cloud application architect with AWS ProServe based out of New York City.
And Iris.
Hey everyone, I'm Iris. I'm a cloud application architect, so I'm working with AWS ProServe and also based in New York City.
And myself, Svenja, an associate cloud application architect based in Munich, Germany. All right, let's get started. So this is the agenda for today. We will start off by introducing why you would want to have integration tests for your application. Following up, we have a look at the integration test constructs that are available in the AWS CDK. And after that, we will spend most of the time looking into the demo example application and the integration test that we prepared. Why integration testing is important? So first of all, what are integration tests? As part of this talk, we define integration tests as tests that are run against two or more architectural components, which could, for example, be a SQS queue and a Lambda function that need to interact with each other. We want to test this interaction in order to validate that those components work as we expect them to work once we deploy the resources and we actually have it up and running. This is important and also useful in order to eliminate potential misconfigurations. For example, on IAM policy level, you may have like missing policies that prevent you from doing things that you were intending to do. There are service limits that you may not have thought about that prevent you from actually making your workloads work as expected, plus anything around application configurations and runtime code that can be tested once deployed to the cloud. To make this a little bit more tangible, we have an example here, which is an Amazon SQS queue on the left side with messages that are being picked up by the AWS Lambda function on the right side. Now, if we imagine that we have a system that actually has those two architectural components, what could go wrong? First of all, the Lambda function's execution role should have the required IAM permissions to actually be able to consume the messages from the queue. Secondly, there are service quotas that we have to think about, such as, for example, the message size on the Amazon SQS queue. And those are just two examples of things that can be validated by using integration tests. Let's dive a little bit deeper into the AWS CDK. What do we have in the library? So what we are going to show you is based on two components. The first being shown on the left side, which is the integ-test alpha module. It's an alpha module, meaning that it's still subject to change. And this module has a construct which is called the integ-test construct, which allows you to sign up your stacks for integration testing and actually write the integration test itself. It also has utilities to make assertions against the resources that are being deployed, such that you can customize the behavior that you would like to validate and test. On the right side, we have the integ-runner, CLI, which is the CLI part that helps us to deploy and destroy the test case stacks. This CLI contains various options to further customize the test run behavior, which we are going to see in the demo later on. And it is also used to verify the snapshots. So there are different expected behaviors, also something that we will dive into later on. Without losing more time, let's take a look at the sample application that we have. So in order to show integration tests in action, we chained a bunch of services together. So this sample application has an Amazon SNS topic, which is connected to an Amazon SQS queue, meaning that the notifications are sent to the SQS queue. The messages there are picked up by an AWS Lambda function, which processes and enriches the message before writing it into a DynamoDB table. What do we want to test? We want to test the entire data flow. So we will start on the left side by publishing a message, and at the end of the test case, we expect this enriched message to be available in the DynamoDB table. This being said, let's take a look at the code. Iris.
Amazing. Thank you, Svenja, for introducing the sample application. And now let's take a look at the code on how we would actually write integration tests for what Svenja just described. So automating the test as we publish a message to SNS and ensuring that this message with all the transformation and enrichment is actually persisted in our DynamoDB table. So we are going to start the integration test stack implementation by actually starting very similar to what we do with any other CDK application. We will start by creating a CDK app. I'm pretty sure you're familiar with the first part here as we create the CDK app and also the stack, which contains our application resources linked to the CDK app. So it's important to create an app because all the integration test constructs using the integ-test CDK construct should be created in the context of a CDK app. All right, so we create the stack under test here, containing all the resources that Svenja just introduced, so the Lambda function, the DynamoDB table, the SNS topic, and the SQS queue. So far, so good. This is very similar to any other CDK application. We now need to register this application stack as part of the integration testing construct. So we start by initializing the integ-test construct, and this construct is actually going to create a stack, as we'll see once we run these tests, which contains all the resources which are required to validate and assess our application. First of all, we register the test cases. So what we're doing here is just registering the application stack as a stack which will be created in the context of the integration tests. We can register multiple test cases as well. And also very importantly, as Svenja mentioned, this integ-test construct is actually designed to be used with the integration runner command line interface tool. So this part here is important to be able to customize the behavior of this integration runner as this tool is going to run the CDK commands. In our sample here, we're keeping it simple. We are simply saying that the integration runner can destroy every resource, every stack from created in whether that's from the application stack or the integration test itself, without asking for human approval. Any options which can be supplied to the CDK commands can also be customized in here. All right, great. So now it's time to start with writing some assertions. So we have our application registered as part of the integration tests. Now we would like to start by publishing a message to our SNS topic. And as the application continues with the data flow, moving this message to the queue, and then the message actually being pulled by the Lambda function to parse and enrich it and save it to DynamoDB, then we want to ensure that this item is exactly as we expect in the DynamoDB table. Great, so we will start by leveraging the AWS API call method from the assertion stack. So in this case, we are configuring the service to be SNS. We'd like to issue a publish API call here. And of course, we can provide all the different parameters that the SNS publish API supports. In this case, the topic ARN is actually a required parameter. And note how here we can actually get the topic ARN from the application stack. So as this is exposed as an output of the CloudFormation stack, we can actually use it as part of the integration stack as well. And of course, we're going to pass the message itself, which actually contains the ID, which is a static ID in the context of the integration test, and also a text message. Great. Now, we are almost ready to actually validate that the message is in DynamoDB, persisted as an item there. We're going to ensure that the DynamoDB get item API call is called after the SNS publish API call. And we can do that by chaining the commands using this next method here, which is also coming from the assertions class. And of course, in this case, we are actually testing an asynchronous data flow. So the message is going to move through various services, and it's going to take a few seconds to actually reach this DynamoDB table. And that's why we can leverage the wait for assertions method and feature of the CDK integration tests construct, so that in our instance, we wait a total of 25 seconds for this item to reach the DynamoDB table. And we are going to check every 3 seconds that the item is there. Now, if the 25 seconds are done and the item is not there, the test is going to fail. But if we find the item within this total timeout time here, then we can finally expect the result by comparing the actual result with the expected result. So the expected result class from the integration test construct is very important here, as we can use various methods of this class to do the matching itself. In our case, we're expecting an object back from the DynamoDB get item API call. So we're going to match against this object. And this object should include the item with this ID, the text message, and also with the additional attribute, which is enriched by the Lambda function. Other methods that can be useful for comparing the expected with the actual would be comparing, for example, arrays with the array with method. We can compare exact values, which can be of different types, such as strings, numbers, and also we can check different strings by using regex patterns. All right, great. So now we have the test ready, and it's time to run this test. And so the test is now starting to run, and I have, first of all, added the directory argument to this command, as all of our tests are actually as part of the integration test directory. Now, this integration runner tool is going to check for any test files which start with the prefix integ-dot within the directory that we supply here. Now, we can specify different regions to run this integration test against, and all these executions would be done in parallel in each of these regions. In our case, we'll keep it simple to one region. And finally, we would like for our test to update the test and also the snapshot created for that test if the snapshot check fails, as it has in this case. So right now we're running this test for the first time. there is no snapshot available. So it's going to continue running the test, generate this snapshot, and save it in the code. Philip is going to talk more about this and how snapshots work. Awesome. Now, this test is still running. Let me show you what's happening in CloudFormation. Amazing. So now we have our resources deployed. As you can see here, we have now 2 stacks which are being created as part of this execution. So this is the application stack, which contains the queue, the function, our DynamoDB table, and the SNS topic. Now note how there is another stack actually created in here for deploying mainly Lambda functions and also custom resources, which are going to run all of our API calls that we actually configured in the test case. So for example, notice here that we have a custom resource, which is going to call the DynamoDB get item. All right, so this test has completed, and if you saw, like I just refreshed, and now it's deleting both of these stacks. As what we've done is actually set in the code here, we have configured the CDK commands to actually clean up everything once the integration runner is done with running those tests. Now, I encourage you all to take a look at the resources that we're going to share with you and the documentation of the integration runner, because there are more customizations that we can have in place, which work for our workflows. So, for example, if you would want to keep all the stacks up and deployed even after the test is finished, we can use, for example, the no clean argument here. And this could actually be super important during debugging and writing the integration tests, but also if our application stack contains resources which take a lot of time to deploy. So for example, there are RDS instances which can take a lot of time to deploy, and if we want to run tests frequently, then we can shorten the time by running the test on already deployed stacks. Great, and with that, now we have the test running, we have the snapshots here, and I'm going to let Philip talk more about how the snapshot lifecycle works.
Thank you, Iris. When you run integration tests with CDK, there's a few things that you want to consider. So the first feature I want to talk through is snapshots. Snapshots are created after each integration test run that you write, and effectively they maintain a state of the last successful execution. In this scenario, when we first started out, there were no snapshots for these integration tests that we had written. So when you ran the integ-runner CLI, it first checked if there was a presence of a snapshot. Because there was no snapshot, it then went ahead and synthesized the stack for testing your application with these integration tests. Now, on subsequent runs, you'll see that it saved the snapshot. On subsequent runs, the snapshot is used to check and see if there's been any changes in your test cases, in your actual code. And if it's a test that they detect no changes, then it uses a snapshot and it skips those. And that makes it faster for when you run your integration tests. The other thing to look at is retention policies. For retention policies, after you run your integration test, Iris was talking about a clean, no clean flag. When you specify clean, it destroys the stacks right after the test pass is complete. But for some resources in your stack, for example, CloudWatch log groups, those resources might have a retention policy set as retain. You're running a bunch of integration tests, spinning up the stacks. You don't want to have orphaned resources just retained in your account after each test pass. So to handle these, you want to use a mechanism like aspects to go in and update these resources policies. You can see here there is an applied destroy policy aspect that visits each construct And if it is a CFN resource, we apply and update the policy to destroy. Great. We're excited to share this information with you as an introduction to integration testing using CDK constructs. There's a lot more documentation. We've created personally a blog post, and we've also have a code sample for you to walk through and explore at your own pace. There's also AWS documentation on these two constructs that you can browse through. Thank you for joining our session today. I want to invite our other speakers, Iris and Svenja, onto the stage as we close out. We hope that you were able to take away how to use AWS CDK constructs to run integration tests in your own application. And if you have any questions, Iris, Svenja, and my emails are listed here. Feel free to reach out. And we're looking forward to hearing your feedback on the session with this pulse survey on the right. Take care and happy building.
Thank you so much. And we are back with Andra. Together we are supporting the fun time and also a quiz time, because that's the time for the quiz on our agenda. Should we go straight to the quiz, Andra?
Yeah, let's try with that. Let's see who is here and who is paying attention so we can reward them.
Okay, good. So yeah, let's split the roles. Andra will be carefully evaluating the chat, because answers should be actually provided on the YouTube chat. And I will try to level up the rules. We have some HashiCorp goodies to pass, and we would like to have 2 winners for that question. Question will be stated at the end, obviously, and we will have 2 answers to provide. Both should be correct, and both will be actually affected by the question. Both winners, we would like to ask both winners to reach out to Andra on LinkedIn to actually confirm that they're winning, that they won, and that they actually can receive the packages. And also they can join to the CDK Dev Slack workspace that is advertised throughout the day, because that will be also a very easy way to connect when it comes to the goodies and handing them over. And regarding the question, or actually questions, because we debated if we would like to have a 1 answer or 2 answers, but let's go with 2 answers. So the fastest answer will win, and we would like to hear from you. At what date CDK was released? But the 2 answers should be about developer preview and the general availability. So if you know those dates, let us know in the comments. And actually, the closest dates and the fastest writers will win.
Yeah.
So let us know if you know the dates. Reminder, when exactly it was for the developer preview and when it was for the general availability. I think people are furiously Googling that stuff at the moment, at least some of them.
I see some 6 years ago. Yeah, we need a specific date, Jordi.
Exactly. 6 years ago is, it's a good estimation, but we need closer one. Okay, we have July 11th, 2019 for GA. Andra, can you confirm at least this one?
I won't say anything. I'm taking the note of the name of the speaker.
Okay, we have Kenny with 1 answer. If someone would like to pass, there's another chance. Glib is actually providing another answer for the developer preview. Google helped. I hope it helped well. We will see. Maybe we'll give a little bit more time to the others to actually answer. We will see. Kenny asked ChatGPT. Okay. I don't know if that helped you or not. We will see. Yeah.
Show it to the stream.
Kenny actually proposed July 11, 2019 for GA.
Yeah,
and
that's right.
That's correct one. Yes, and that was the fastest one. And also Glib provided the answer for developer preview, 27 on August 2018. That's also a correct one. So congrats to Glip and Kenny. Please reach out to Andra on LinkedIn. This way we will be able to contact you, and from there we will orchestrate the delivery of the rewards. Thank you so much for participation.
Happy to see you're not sleeping and you're...
Exactly, because we are spread out all over the world. And also, you can give us a shout out in the chat at which country you are hearing us at the moment. So let us know if we are heard in Europe, maybe in States, maybe in other places in the world as well, especially that we are throughout the whole time zones. I will leave you, Andra, with the next speakers and next stage setup. So ready to when you are.
Yeah, sure. Thank you, Wojtek. Thank you for all the support today, actually, to our amazing hosts and also the speakers. Next up, we have Dr. Rahul and Sharad with an interesting talk about CI/CD, containers, and CDK. This will be very fun. Let's hear them out.
Hey, hello everyone. Thank you so much for joining our session and welcome to the CDK Day series. Today we are going to talk about one of the solutions which we built using ECS Anywhere, CDK and GitLab to solve customer challenges for their hybrid and containerized workload. Let us deep dive. My name is Dr. Rahul Sharad Gaikwad. I am a lead DevOps at AWS. I am part of Proso team where we help our global customers to migrate and modernize their workload on AWS Cloud. Along with the DevOps work, I completed my PhD doctorate in artificial intelligence in IT operations. Outside the work, I like to travel across the globe. So far, I have traveled 10 plus countries in the world. We attempted to be creative here so that we have created this introduction in CDK template. And today we are happy to join this session with my colleague Sharad Pothulla. He will walk us through the demonstration of this solution later in this session. For today's session, we will follow this agenda. I will walk us through a couple of use cases, and then we will discuss about the challenges which customers are facing with their hybrid workload and containerized applications. I will talk more about the benefits of having ECS Anywhere in your environment. Then we will talk about one of the customer challenge which we solved using our solution. Then Sharad will demonstrate the solution and we will conclude with the call for action. Let us discuss a couple of use cases. The first use case is the hybrid workload. Traditionally, as we know, customers are running their business critical workload in containerized application, either in on-prem or on the cloud. This use case is talking about the customer who need to run their containerized application in on-prem as well as on the AWS cloud. In such cases, there might be possible reasons like data gravity, compliance, and latency requirement. In such situation, customers are always looking for a single orchestrator platform to run their business applications and their deployments across the environments. Let us discuss another use case, that is on-premise investment. Suppose customer has invested lot of money in their tooling or maybe in their on-premise infrastructure in licensing cost. Now they want to utilize all their infrastructure cost until they have fully paid off. During that, customers want to leverage their compute resources as well as expertise to manage their business critical workload. With that, let us understand how Amazon ECS works. Amazon Elastic Container Service is a fully managed containerized orchestration service which simplifies your deployment, management, and scaling of your containerized application. You just need to define your task and the resources, and ECS will take care of launching, monitoring, and scaling your application based on your need. and it will provide you the options to choose your platform such as EC2 or Fargate and many more. With this current deployment model, customers are facing few challenges to run their containerized application. Customers do not want to have a multiple operational models to run their business critical systems on cloud and on premises. Customers may have done the capital investment in their data centers and now they need to amortize before they move onto the AWS cloud. Customers may be having in specific industry or regulated markets where they are forced to own the infra operations for compliance reasons. Customers may need to have applications deployed close to their data center for higher bandwidth and lower latency. Now, what is the solution for all the challenges and use cases which we just talked about? Amazon ECS Anywhere is the solution which was launched in May 2021. Let us understand how does Amazon ECS Anywhere works. Suppose you have a customer data center and you have a AWS cloud. You need to register your server or virtual machine which is located in your customer data center. You have to register it with Amazon ECS cluster. It will be referred as an external instance. You have to install Amazon ECS agent as well as AWS SSM agent, which will be communicating to the Amazon ECS control plane through transport layer security, that is TLS protocol. So let us discuss what are some benefits customer can expect using Amazon ECS Anywhere. ECS Anywhere provides a unified and fully managed control plane that will be running in AWS cloud and which will be always up to date. It allows single management interface and API for all your container-based application. You do not need to create a new task definition to run your containerized application. However, you can reuse your task definition without any modifications to create multiple services in the same cluster. ECS Anywhere ensures consistency in tooling and governance when you migrate your application from on-prem to AWS. As I mentioned earlier, all the communication between control plane and the external instances will be over transport layer security, that is TLS protocol. In the disconnected scenarios, ECS Anywhere tasks will continue to run without any failure. Just a quick recap. So far we talked about few use cases, challenges and the solution using Amazon ECS Anywhere. Now I will be focusing on one of the problems which we solved using ECS Anywhere and CDK and the GitLab. The problem statement is customers who are already running their container application using on-premise infrastructure and managing all their application code base using GitLab repositories. But now customer decided to migrate their workload on AWS cloud. They want to manage all their application using AWS cloud services without disturbing and sacrificing their existing on-premise infrastructure and the investment. Now let us talk about the solution which we developed to solve this problem. This solution is designed to help those customers who are managing their all infrastructure in their on-premise and running their application code base into GitLab repositories. On left, you can see the corporate data center, which includes GitLab repositories and their on-premise VMs. You can see in the diagram there are two flows. The one is talking about setting up the ECS cluster, and the other workflow is specifically deploying CI/CD pipeline and your application deployment. Let us deep dive. The first CDK stack will provision the CloudFormation stack which will internally provision the Amazon ECS cluster. Then, once you install the Amazon ECS agent and SSM agent on your VM, it will be considered as the external instances and it will get registered to the Amazon ECS cluster. Then you can use that external instances to run the multiple containers on that VM. Let us talk about the second workflow, which will actually have the CloudFormation stack. It will create a CI/CD pipeline, which will include code commit, code pipeline, code build, and code deploy services. You can deploy your application through this CI/CD pipeline. Whenever you push your code to the GitLab repository, it will commit all that code onto the GitLab repositories. We have set up a mirroring between GitLab repositories and code commit repo so that whenever you push your code changes to your GitLab repository, it will automatically replicate onto the AWS code commit. Then, as soon as we receive the changes in the code commit, it will trigger the CI/CD pipeline. Then it will build your container images and then it will push that images to the ECR repo. Then code deploy will pull the images from the ECR repo and then it will deploy your application code base to the ECS cluster. However, ECS clusters will run those tasks against your on-premise VMs in the form of containers. That's how this solution will work. Now I will hand over to my colleague Sharad for demonstration of this solution. He will explain how all the CDK stacks will work together using a CDK TypeScript. Sharad, please take it away. Thank you.
Thank you, Rahul, for explaining the use cases, challenges, ECS Anywhere benefits, and the solution. Hello, everyone. This is Sharad Chandra, and I am a DevOps consultant at AWS. Today, I would like to demonstrate how we can set up ECS Anywhere workloads using AWS Cloud Development Kit. Here is my short introduction, which I have developed using AWS CDK TypeScript, and I have passed my inputs like name, designation, company, address, skills, area of expertise, and interest in CDK.json file, which I have highlighted. Before going to start our demo, there are some prerequisites like we require active AWS account, Node.js, NPM, AWS CLI to be installed and configured in our local environment with the latest versions. And here I use for Node.js 18.16.0 or later, and for NPM I have used 9.5.0. And the source code which I have highlighted here is for our demo. Open any of the terminal, clone git repository using git clone command. Once it got completed, then set up AWS profile in your local environment using AWS configure command. It will prompt for AWS access key ID, secret access key ID, region, and default output option. I have used Visual Studio Code for our demo, and code was developed using AWS CDK TypeScript. Highlighted one will create ECS Anywhere infra stack, which will create VPC, ECS cluster, ECS service, ECS task definition, external instance, and supported IAM roles and policies. We need to install AWS CDK latest version using npm commands, which I have highlighted. Once it got completed, then run npm ci command to download and install the packages which are mentioned in the package.json file. After CDK installation, we need to bootstrap AWS account using CDK bootstrap command. Once it got completed, then do CDK ls to list down the available stacks. So then we can synthesize the specific stack using CDK synth command, like which I have highlighted here. If there are no errors in CDK synth, we can now deploy our infra stack using CDK deploy command. I have initiated CDK deploy command for creating ECS anywhere infra stack. It is now prompting for creating IAM roles and permissions for ECS task definition, external instance role, and creating a log groups. CDK deploy command is prompting to create above resources like IAM roles and policies. I have given S2 proceed to create CloudFormation stack. Now the CloudFormation stack got created for ECS Anywhere infra stack, which has created the resources like ECS cluster, ECS service, ECS task definition, and the external service with the supported IAM roles and policies. ECS Anywhere cluster got created with the active status. I have configured external instance, which is a on-premises instance in ECS Anywhere cluster, and ECS service got created with replica of 1. ECS task definition got created, and I have used Nginx as a base image with the minimum compute capacity. Now let us see how to create and register external instance, which is an on-premises instance with ECS Anywhere cluster. I have used Vagrant and VMware Desktop as a provider for Vagrant. Use the highlighted commands to install VMware utility and plugins. Use Vagrant file configuration, which I have highlighted to spin up the virtual machine using Vagrant VMware. Locate the Vagrant file path and run Vagrant up command to spin up the virtual machine using the configuration mentioned in the Vagrant file. Once virtual machine got created, we need to log into VM using Vagrant SSH command. After we log into VM, we need to install AWS CLI to execute AWS commands. Then log in as a root, execute the curl command, which I have highlighted. It will download the ECS Anywhere install script to run SSM agent, Docker, and Docker agent in the background to register our on-premises instance with ECS Anywhere cluster. And once it got successfully installed, then we can able to see our external instance, which is an on-premises instance in ECS Anywhere cluster as a external type. So far, we have created ECS Anywhere infra stack and pipeline stack to be created to enable CI/CD. Highlighted one will create ECS Anywhere pipeline stack, which will create the resources like code build, code deploy, and code pipeline. Now, let us deploy ECS Anywhere pipeline stack using CDK deploy command. It will prompt for IAM roles and policies which are required to create ECS Anywhere pipeline stack. Click S to proceed to create CloudFormation stack. CloudFormation stack got created for ECS Anywhere pipeline stack, which has created code commit, code build, code deploy with supported IAM roles and policies. CI/CD is now enabled for ECS Anywhere workloads. Whenever any new source code check-in comes, it will automatically pick it up by code commit and do the build using code build and deploy using code deploy. That's all for demo. Hope you have got some understanding. Here are the references, call for action. Please go through it. If you have any queries, please reach out to us and follow us on LinkedIn. Thank you.
Hey. So.
Hello back. So I think we need to thank for amazing work that is done by the SL interpreters. I think we didn't praise them enough for their hard work that is being done. We are having at the moment switch between Sarah and Ben. And I would like to also mention that I really enjoyed the day so far. What was the best session for you, Andra, regarding the highlight so far?
Well, all the sessions were amazing. But if I was to choose, let's say, like this year, I've been given some talks about CDK in Bucharest, Romania, and people here are like starting to hear about CDK and are really like starting on this journey. And the like most frequently asked thing was, how do we test? So I guess the testing part is like a very important one, at least for the community here. They are embarking in this CDK journey, and how to test and what are the options, what are the best practices there is really, really helpful. What about you?
I'm smiling because you stole my my parts. I definitely would like to see more talks about testing, especially about the integration bench that was presented with this for the CDK. And I'm also extremely curious about how the Winglang will evolve as a thing, because that talk was impressive and also very, very interesting from the perspective of someone who, when I started using CDK, my primary interest was to actually seeing how much this can improve the software quality and also software development lifecycle process for the infrastructure as code. So I would love to see more about how Wing will evolve as a language and what it can provide to the table when it comes to the software quality management, all the tests that were presented on the talk by Eyal. So I would also highlight those two sessions. But also I really like the session about the Projen. This is, as someone said earlier, I believe, Ben and Satya, the amount of contributors and naming everybody that contributed and also provided the support, that was extremely valuable and interesting. We should also praise those contributions to those projects, because that's how the community is built. But I also like the announcement that was made about the PDK, that it's pretty interesting thing to have in general. And Projen as a tool will be very helpful in those scenarios, especially for bootstrapping such stuff like the monorepo presented there. So I would, if I cannot highlight the same thing, I would go with the Projen talk. But I will go with software quality and that testing as well.
Yeah, that's a very good answer, actually. Yeah, should we talk about the next session? So soon, in like 8 minutes, we'll have on Neelam. She will talk about a very discussed topic these days, so Gen AI.
A hot topic, and also very interesting from the perspective of the infrastructure as code, because we will see how to use CDK for Amazon SageMaker and SageMaker Jumpstart in particular. I'm actually interested if there's anybody on this live stream at the moment that it's using CDK for developing infrastructure for ML, for MLOps. Let us know in the comments, because we would love to see what would be, if there are any people that are actually using this in the wild. That would be awesome to see such examples. But I'm also pretty interested in the talk that is upcoming, because this will give us a lot of interesting insights how to build those things. And as you said, topic is very hot and very interesting. And especially that yesterday we heard that Amazon Bedrock was generally available and announced with some of the features. So that's also a very interesting moment to have such talk, even that it's not about Bedrock, but still about Gen AI.
Yeah, you ruined my surprise. I meant to ask the the community out there, what's another product out there you are using, or why not large language model that you are using, other than the famous one already mentioned on this stream. So Wojciech gave me one. What's yours? It's hard to believe, like, you might have missed the Gen AI wave, and you might not be involved in it. That's completely fine. But if you are, and if you are doing something, let us know what you are using, and yeah, anything you like, or any project you have going on. That would be interesting.
Maybe someone will have an opinion on the chat how Gen AI will help us developers and operation engineers in managing infrastructure as code and complexity regarding operations. I would love to see products, stuff that will actually manage this, because that would be very interesting from that perspective as well. Maybe there are some interesting insights from people out there. Let us know in the comments. We are having 5 minutes until the next session. So if there are any comments not related with the Gen AI or the next sessions, let us know as well. Otherwise, we will go and maybe schedule a quick bio break. Andra, what do you think?
Yeah, let's have a hydration break, like Satya said, and we will come right back with Neelam Koshiya and her talk about Gen AI and CDK. We will be in the comments. See you.
See you in 5 minutes.
Hello, everybody. Welcome to my lightning session for CDK Day event. In this session, we will work together to deploy a generative AI model using AWS CDK. My name is Neelam Koshiya, and I'm a principal solutions architect at AWS. My background is software engineering, and I organically moved to architecture role with my area of depth being machine learning. So this session is primarily marrying machine learning with engineering or DevOps component, which is CDK. Now, the session is a short 20 minutes duration, and what best way to deliver this than working together to deploy it? My slides are limited to highlighting some details and concepts that will help lay the foundation or baseline for our audience today. So let's jump right in. Let us begin by asking, where does Gen AI fit in? Yes, Gen AI is a subset of deep learning, which is a subset of machine learning, which all rolls up to artificial intelligence or AI. The seed of machine learning paradigm shift have existed for decades, but with readily available, virtually infinite compute capacity, massive amount of data, and the rapid development of machine learning technologies, customers across industries are rapidly adopting and using machine learning technologies to transform their business. Just recently, Gen AI applications have captured everyone's attention and imagination. We are truly at an exciting inflection point in the widespread adoption of machine learning, and we believe every customer experience application will be reinvented with generative AI. Let's take a step back and see, how did we end up here? What happened suddenly? It didn't really happen overnight. Natural language processing has been around for many years, but it experienced kind of a renaissance with word-to-vec. Some also call it shallow neural network. Then in June 2017, there was a paper which was published, and it introduced transformer architecture and concept of attention. The paper is pretty popular even now, and the name of the paper is Attention is All You Need. Highly recommend reading that. Now, the biggest architecture after that, like GPT and BERT, are still around. And yes, the T stands for transformer, and both are leveraging transformer and attention. Now, what happened over the years? There was improvement in parameters, and with development improvement in compute capacity and data, the model eventually jumped from 1 million with an M to 1 billion with a B, like GPT-3 having 175 billion parameters. Now, this is when we started talking about LLM, also called as a large language model, and community came together to build more and more open source models. Now, the ones in red here are open source LLM models. This is the phase we are in right now, and we see every week there is new models, and we are seeing increasing emergence of AI/ML startup focusing on large language models. Now, let us ask the most important question, right? What is actually generative AI? So generative AI is a type of AI that creates new contents and ideas, including conversations, stories, images, videos, and music. Like all artificial intelligence, generative AI is also powered by machine learning models. These are very large models that are pre-trained on vast corpuses of data, commonly referred as foundation models. Recent advancement in machine learning has led to the rise of models that contains billions of parameters or variables or features, as we call them. Now, why are foundation models so popular? So if you look at a traditional machine learning model, in order to achieve a specific task, say in this example, text generation, customers need to gather labeled data, train a model, and then deploy the model. Now that's a paradigm shift versus how foundation model work. So for a foundation model, instead of gathering labeled data for each model, for each task, and training multiple models, customer can use the same foundation model and adopt it to various tasks. For example, you have various foundation models being trained on Wikipedias of the world. And that particular model, also known as the foundation model, can then be used to adopt a different task like text generation, summarization, Q&A, chatbot, etc. Now, the beauty of foundation model is that foundation models can be customized to perform domain-specific functions that are differentiating to their business, using only a small fraction of data and compute required to train a model from scratch. So now that we have talked about the Gen AI part of the topic, let's focus on the other part, which is CDK. So AWS CDK is an open source software development framework to model and provision your cloud application resources using familiar programming language like Python, Java, etc. Now with CDK, you will be much more faster than with any previous tool to, have that fast cycles from conception to deployment and then maintaining it, because you would work with familiar language like we're going to do in Python today, and concept, and the same familiarity with classes and methods without doing context switching. With CDK, there is actually a paradigm shift on how we provision multiple environments. Previously, with CloudFormation, we had one template with parameters for multiple environments like dev and test. Whereas with CDK, there is a shift wherein you can have multiple templates that would generate code and stacks for each environment. So now that we have a baseline idea of the two pieces, which is Gen AI and CDK, let's now talk more about what project we are going to deploy together today. Here we are in Hugging Face. So Hugging Face is a repository where you can look for models, data set, etc. And we are going to access two of the models which is available in Hugging Face for our example. So the first model is by Stability AI. It's called as Stable Diffusion 2.1 base. Now, what this model actually does is it takes a text as an input and it creates, based on the text prompt, it creates an image. So it will take text as an input and the output will be image. And then if you look at this particular page, you can, get more details about how the model was created, what is the licensing, and who developed the models, etc. You can also additionally take a look at how many times this was being downloaded. So it's a pretty popular model, specifically in the image space, and it has around 600K downloads. So that's first model, which will help us to do image generation. And the second model that we are going to use today is Google's Flanty 5 XL. And this particular model is going to help us generate text. So here is a good picture about the multitask instruction fine-tuning that you can do. However, I'll just scroll down and we can, look at more details about this particular model, how it was trained. So it is under the Apache 2.0 license, and then there are more resources and you can read more about it. And you can also check on how you can use the PyTorch model and how you can run this model on CPU and on a GPU. And then what are the uses for this particular model? You can read more details about it. But basically, it's going to take a text as an input and generate do things like natural language understanding, like summarizing the details, in our example, but basically doing text generation. Now, the project that we are going to use is the project called as Generative AI SageMaker CDK demo, which is in the AWS sample. And that's how we are going to, there are instructions here, but we will work together to today and demo it. To show you how we can deploy this project. And then the project is leveraging something called as Streamlit for its front end. And what Streamlit is actually doing is it's a simple open source a Python library, which makes it easy to create custom applications for machine learning and data science. And it's honestly few steps, very quick to get started. You can get started with Streamlit on your favorite IDE. And then once you have a decent code, you can push it over to AWS by using few lines of code. And Streamlit works great. Like the way you can deploy the Streamlit application is using the Copilot, which will simplify the deployment to Amazon ECS. So another thing that we'll be using today is the SageMaker Jumpstart. So SageMaker is a fully managed service. So if you go to SageMaker in your AWS console, you can read more details about it. But basically, it's a fully managed service which helps you through the end-to-end life cycle of machine learning, from building, training, tuning, at scale. And one of the components that we're going to use today from a SageMaker is the Jumpstart. And in Jumpstart, you can see it opens up in something called as SageMaker Studio. So SageMaker Studio is essentially an IDE where you would be, ideating, deploying, having ML ops, etc., everything in one place. And over here in the SageMaker Studio, you can also see the Jumpstart. So what Jumpstart is, it's actually a repository where you can find the pre-trained models, we can find solutions. There are other resources like notebooks. If you want to find something specific to frameworks like TensorFlow, PyTorch, you can go and find that. And you also have a search bar here where you can look at the different models which are available. And you can also deploy those models by using a one-click option. So here are some of the text generation models. So some of the more advanced like Llama, Jurassic Family, Cohere command is here. And then we have image generation. And then if you're looking for end-to-end solutions, that is available here as well. So now that we have some of the key pieces highlighted, let's take a look at the architecture diagram. Now that we have provided some context about AI, Gen AI, and CDK, and some of the pieces that we're going to stitch together to put this process, we will now deep dive into our architecture flow. There are two pieces to the application. There is a web application front end and the back end. So the web application front end is built on Streamlit, like I mentioned before, which is an open source Python library that helps you to create web apps in a very simplistic manner, specifically great for ML and data scientists. And we will host this using web application, which is running on ECS. So here we are, and this is the AWS cloud, and we will be deploying the web application, which has the application load balancer, and then hosted in containers, specifically ECS, which is pulling out the image from ECR. Now let's talk a little bit more about the backend. So the generative AI model endpoints are launched from Jumpstart images in ECR. So we have SageMaker Jumpstart, and then we also have ECR, which is actually storing the container images for those models. And then S3 has all the artifacts like the model data, etc., which will be referred. The models are hosted with SageMaker endpoints. SageMaker endpoints, which will be actually referring to the ECR for the image and S3 to host the models. And then the endpoint, which is hosted in SageMaker, will be fronted by or exposed as an API by leveraging the famous serverless combination of an API gateway and Lambda. And we have two different APIs. One is for the text generation, other one is for the image generation. And like I mentioned, both of the endpoints will be referring to the image and the artifacts in S3. And our front end will be calling these two APIs which will serve as a backend. And then we will be having our AWS CDK, which will help us to orchestrate and deploy this particular project in the form of a CloudFormation template and get it ready for us to test it out. So now let's have a practical implementation and let's do it together. There are some prereqs that are required before. So let's go ahead and make sure that we have those prereq installed. So first one is having the AWS CDK. So I'm going to do npm install the CDK library. So next up, we're going to check the CDK version. So let's take a look and check the CDK version. And then let's ensure that we have Docker installed and okay. So, and the version of the Docker. I'm going to do the git clone of the project. That we share is the project in the IDE. So there are different folders in this project, and I just wanted to highlight, what folder has what. So basically the stack folder over here has the different stack that are created for the CDK application. So if you look at this, we have the VPC network stack, which will actually create the basic networking construct, right? Create the VPC, security group, subnet, etc. And then we have the web stack, which will actually be deploying the Streamlit application, the web application with the ELB, the containers, everything into AWS. Basically helping us orchestrate and deploy the web stack, which is the front-end web application where we will be doing our testing. And then we have the two other stack, one stack, which is for the text-to-image, which will be deploying the end-to-end flow for the text-to-image, including the SageMaker endpoints and the other artifact aligned to that and the Lambda functions, which will help us to create those serverless API to call those models. Similarly, for the text generation as well, which is text to natural language understanding text. Now, if you look at the code, you can see the code for the two Lambda functions. So here's the code, which is for the text to image. Basically, what this Lambda function is doing is it's invoking the SageMaker endpoint by leveraging the invoke endpoint API. Similarly, for the natural language processing for the understanding for the text generation as well. You can also see the cdk.json file, which actually tells the AWS CDK toolkit how to run this particular application. So it has the details about that. And then we also have the web app folder in here, which is actually our Streamlit application, which has our homepage, wherein this will be the page that will be displayed when we are going to have the web application front end and all the other pages under it. So we have one page for text generation and one page for image generation. Let's take it further and deploy this application in AWS. So first thing we are going to do is we are going to create a standard Python project, and we will create a Python virtual environment. After that, we will activate the environment. And then we want to make sure our libraries are up to date, specifically the pip. So let's install that. And then we will also install the requirement. While that is getting downloaded, just wanted to uninstall, just wanted to show you the different requirements for this. So basically we need the Boto3, the matplotlib, matplotlib, request, Jinja, and Streamlit for our application, and that's what it's doing. Before you deploy any CDK application, you will need to bootstrap a space in your account and the region that you're going to deploy in. And typically, when you do AWS CDK, AWS configure, you are actually using the AWS CLI to connect to the AWS environment. So before doing that, I highly recommend doing AWS configure. Make sure that you have a profile set and then use this command to bootstrap. Okay, so in a couple of seconds, you'll see a CloudFormation template in the AWS account where you have set up on your AWS CLI. And you can check the different events that has happened, but most importantly, you can check the resources that were created as a result of this particular CDK bootstrap command, right? So it created the staging bucket, it created the roles, IAM roles, policies. So now let us begin by doing the CDK deployment for the different stacks. Remember, we mentioned about the 4 stacks, right? So the first stack is the foundational stack, which will create the VPC network constructs for our project. So let's deploy that. So once the networking components are deployed successfully, we will then go ahead and deploy our web front end by using CDK deploy the web stack. And then similarly, we will deploy our text generation stack as well. So our deployment of that particular stack is complete. So you can see in your CloudFormation that it is complete. Now that we have deployed one piece of it, let's go to our web stack, get our URL, and try it out ourselves. So here's the web stack URL. And you can find it out in the output of that particular stack that you have deployed. So this is our URL. Isn't it looking really cool? It's a Streamlit application, and these are the multiple pages that we have created. So let's try the one that we have already deployed, which is the image generation. So this is a simple prompt, and I'm going to generate an image. You can also see details like the API gateway URL that it's calling and the endpoint. So let's generate the image. So there you go. That's our dog in a superhero outfit. Isn't it really cute? So similarly, you can deploy the next stack, which is the text generation, and try out that as well. So let's go ahead and do that. And let's wait for it to complete the deployment, and then we can try the text generation. Let's go ahead and test text generation. So in this particular example, we are using the same Flan T5 Excel, and this is a interaction between a customer and a customer service center, contact center agent. And what we can do is we can have the context provided over here, and we can ask a query, write a summary of it, and then the model will go ahead and summarize what really happened. So that's one use case. And then another use case is what are the steps suggested to the customer? So you can ask other natural language process query and get more details out of it. So there it is. We have completed the 2 use cases using CDK. I hope you enjoyed it, and thanks very much for joining. Thank you and bye.
Thank you very much, Neelam. That was a very interesting talk. Let's, without further ado, jump into the next talk by Miguel A with a story about their migration from serverless framework and what were the lessons learned there.
Hi, my name is Miguel Calles, and I will be sharing what my team and I learned when we migrated one of our applications from the serverless framework to AWS CDK. So I'd like to start with giving just a quick introduction to serverless computing, which is what my team and I used in our application. So what is serverless? Serverless is a different way of developing. Rather than having a dedicated, let's say, EC2 server where you have to install the packages, configure the runtimes, do cybersecurity hardening. With serverless, you just rely on services to do what you need: compute, database, storage. So it doesn't mean you don't have servers, it just means you're relying more on the services or the functionality that your provider, AWS, provides. So there's different types of serverless services. The most commonly known is functions or code execution. That would be Lambda, or APIs, so API gateway, databases like DynamoDB, object storage like S3. There's also other things you can do with orchestration with CloudWatch events, CI/CD with code pipeline, code build, AI and ML with SageMaker. And you can integrate all these services together depending on your architecture. So why do you want to use serverless? There's different reasons, but really when it comes down to it, it allows you to be more agile and focus more on building and developing rather than maintaining and securing and configuring. It comes in handy when you're building prototypes, when you have a small team, or when you want to provide the most value with the least amount of maintenance effort. So serverless computing or designs, architectures are not a silver bullet. Sometimes dedicated servers have are more beneficial than others, but these are just some common reasons why you would want to use it. So just to share, this is an example of a serverless architecture built on AWS. So in this, we have a serverless website that runs a single page application that a browser can use that web app and run it on the browser. You can use the CloudFront service to just deploy a content delivery network which provides caching at edge routers. That way, when the user goes to your web application, it loads much faster. Then there's also, you can use the S3 service to get hosting on there by using an S3 bucket. And you can connect the CloudFront and the bucket so that way any HTML, CSS, or JavaScript file, image file that's loaded from the bucket gets cached via the CloudFront service. You can also build up your DNS, domain name service, on Route 53. Or you could always use an external domain name service. But if you do it with Route 53, then the automatic deployment of any DNS records is managed through the AWS processes. The backend can also be serverless. What you can do is use the API gateway to send HTTP events to a Lambda function. The Lambda function will run its code, and if it needs to get data, it could get it from a database, like from a DynamoDB table. For example, sites or the web app will communicate with your backend, and then if you have a mobile app, that too can make API calls. So to build our application, we used the serverless framework. We wanted to build a serverless web app and its API, and then a mobile app that worked with its own serverless API. And the team was highly experienced with serverless development and serverless framework, and so that's why we chose that for our application. So in this application, we had, again, a web app and a mobile app. So the web app had its own dedicated API, and same thing, the mobile app had its own dedicated API, and they shared a common backend, so common databases and common Lambda functions. So the serverless framework is designed for services. So when you create a new serverless framework, when you go to the serverless framework and the command you type to create, it creates a new service. And if you want multiple services, you run that create command in different folders. This is kind of following the microservices paradigm, which is very popular and still is when the serverless framework was created. So there were 4 key services that we built. The platform, which is the core functionality of our application. Then we had the account service, which is essentially doing identity provider stuff, authenticating and authorizing users. Then the API is for the mobile app and the web app to get data from the back end. And then we decided it was best to have the web app itself in a different service, since it could be standalone. So the platform service allowed us to set up the hosted zone, which is where the DNS is set up. And we can create our SSL certificates using the certificate manager. Our Lambda function provided the code to power our APIs and also to do the initial setup when we do onboarding or creating of the application in a new AWS account. we did the core IAM security policies, took advantage of the vet bridge to do the background processes. And then we also had a core set of Dynamo DB tables that were shared across the different parts of the application. We use various plugins as well to do certain things. As you'll notice that there are a common set of plugins that will show up in all the services. We built a common set of serverless framework service so we can reuse this on future projects. As mentioned earlier, the counts does the identity provider, so we used Cognito, one user pool specifically for the web app and another one for the mobile app. The web app had one type of user, whereas the mobile app had another type of users, and they would not need to use the other counterpart application. So therefore, we felt it was important to keep that separate. There was also some data that we wanted to keep specific to the account that we didn't want to store in Cognito, so we had separate tables just for account. For the API, we went with the GraphQL approach versus the RESTful API approach. And again, since there were dedicated APIs, there was an AppSync API for each application. And our web app is just a serverless web app, so it was just the S3 bucket, the CloudFront, any related certificates, and those were added to the hosted zone that was part of the platform service. So we had pretty good success. We were able to deploy a minimum viable product pretty quickly. We built a common library, so we were using monorepo, had a common library folder, and any common code was shared across the different services. But we also found that the deployment order was tricky. Some plugins required you to run a pre-deployed command, and then others required you to do a post-deployed command, and sometimes it had dependencies on other plugins or a service resource in CloudFormation, which is the underlying underlying deployment method for Serverless Framework, needed to have been deployed first before the plugin would work. So we found it a little confusing, and YAML is great, but as the file got bigger and as we were adding more, building it up, we kind of found it a little confusing. Not too bad, but just sometimes we had to do context switching. Yeah, and then probably the most annoying part was the IAM policies. There were some plugins that were great, worked well in version 1, but they tend to break on version 2, and then and other plugins also sometimes broke with version 3, and so and then the native way of doing IAM policies kind of relied on using the CloudFormation template YAML format, and that can be tricky. So yeah, so we found it to be somewhat difficult, but it was still awesome. We were able to build, deploy, and get a client using our MVP just within months. Now, as a team in 2021, we decided to try out this AWS CDK. It was at version 1 at the time, and it was in, I don't know, at least over 100 in the minor version. And we've heard some success on it, so future projects, not this one, started using CDK for experiments while we were building MVPs and trying out different product ideas internally. And so we tried that, and we found that it was a different mind shift. We had to not think about microservices, but in apps. So it was deployment apps or CloudFormation stacks. It was just a different way of reorganizing. Both CDK and Serverless Framework used CloudFormation in the underlying deployment method, but the way they're organized is different. We also found that using SSM parameters was actually much easier to work with in CDK than it was in Serverless Framework. And it also, in Serverless Framework, you had to use, if you had like variables inside your YAML, you had to use a plugin to help interpret those variables, because that wasn't, for some of them, they were not native. There were some native ones, but not all of it was native. And then another nice thing was you could build reusable components. So the entire CDK has level 1, level 2 constructs that are ready to go, components you can use to deploy certain resources on services. You can also put level 2 and level 1 constructs together to build a level 3 one, which provided a lot better reuse. So here's some of the constructs we built in level 3. We did one for the hosted zone and certificate, so that way it would create the DNS and any minimum required certificates to have a working DNS for other services to use. We did a function in log group. I was finding that log groups are automatically created the first time the Lambda function writes to the console log, but when they're automatically created, they never expire, and so they use default settings. So we just thought it'd be better to make sure we can configure all the resources that we use in CDK, so that way we can set the appropriate expiration limits on log groups as well, so that way we don't have like 10-year-old logs in the future, for example, using up a lot of disk space and increasing cost. The website one, Serverless Framework had a plugin that did that, and CDK also provided some out-of-the-box level 2 constructs we could use to do it, but we wanted to have, rather than using the multiple plugins, we needed to build and deploy a successful website using the CloudFront and S3 combination. We could just create one construct to do it all, which is nice. And then another one for CI/CD pipeline to deploy our code and do checks in the CI and then deployments in the CD part of the pipeline. So when we were making this mindset shift, we were trying to figure out what services do we want to convert to apps. And we decided that there were really two core parts of the system. There was the web app, which is really standalone. It didn't rely on anything else but itself. And then the back end that had a lot of interdependencies. So even though we had the web API and the mobile app API, they still relied on the same underlying resources or similar services. So we just felt we'll put it all in one backend app, because the API technically is a backend. The web app in CDK, we used the zone and cert level 3 construct to automatically create the hosted zone and the certificates. And then we just used the website level 3 construct that automatically set up all the resources to create the serverless website, and took advantage of SSMs for setting variables, because we would deploy applications in different AWS accounts, and they were the same app. But what changed was maybe like the domain name and certain parameters. So we just put those in the SSM for each account, and it was just one consistent deployment. And so it was a much cleaner. And now the back end, we had to kind of reorganize the services into different stacks. So we started off with database, and regardless of who uses it, rather than having a dedicated set of tables just for the account service like we did in Serverless Framework, all the database tables were created as its own stack. And then any other stacks, like for example the mobile app API that used Lambda functions that talk to a database table, well, that would depend on the database stack. So this is it was essentially the same resources, just reorganized a little differently, and we could add dependencies. One thing we did add that was new, rather than having post and pre-deploy and post-deploy commands using the plugins and then running custom command line deployment setup stuff, we just created a setup stack that we would just have it run as part of the deployment order, and if it was never deployed, then cool, it would do the setup stuff, but afterwards it would never run again because there were no changes to any of the CloudFront CloudFormation resources. So that was nice, made it a lot simpler. And we got to use a lot of the constructs that were just came out of the box with CDK, and then the level 3 constructs that we built using our out of the box level 2 constructs, level 1 constructs. And we really didn't need any plugins. So what did we learn? So what did we learn migrating? There was just a lot of stuff out of the box. We did not need any plugins. We were able to build our hosted zone or certificates natively, just using what came out of the box. Whereas in Serverless Framework, we had 3 plugins to do that, and we had to do it in a specific order. And also in the pre and post deploy parts of deploying that service. And we mainly built all our lambdas using Node, and we had chosen to use the serverless Webpack plugin, and we had to tune that to work to what we needed. But with CDK, it just came out of the box. It was a Lambda Node.js construct, and we just did that, and it deployed. And we did have the option to configure it, but we didn't really have to. So that was nice. It also allowed us to better organize, rather than having these 4 services that had pre-deploy, actual deploy of the service, and post-deploy, and then sometimes a custom CLI command before that and after that. We just put them all in the 2 apps and created the stacks and put the dependencies together, and we can just do a simple deploy command for the entire app, and it just kind of worked. CDK also has a synthesis, so it is able to catch issues like circular dependencies or just malformed, I guess, the coding that result in CloudFormation template issues. It would just tell you before you even try to deploy. And SSM just made it easier than working with .m files and plugins. And we also found it was just easier to work with with security. Building IAM was simple as using a grant function. CI/CD deployment was simpler. We just built a construct for that, and we were done. So thank you very much for listening to my presentation. I hope that you found it beneficial. If you have any questions, feel free to contact me. These are the different ways you can reach me. And if you're interested on the serverless security, I've published a book with A-Press that's available for sale on Amazon, and also I'm releasing the Serverless CDK cookbook on Medium, chapter by chapter. Thank you so much.
Thank you, Miguel. That was really interesting. Thanks for the resources as well. And I will welcome next on stream no other than Quinn with an interesting story about deployments to every AWS region.
I used to believe that the CDK was a cult. And now I'm urging you to come join the religious cult with me, because I'm in the cult. And if 3 more of you do, I'll get a free toaster. Let me explain how I changed my entire perspective on what has become an awesome tool. I'm Quinn. I shitpost for fun because I have deep-seated personality problems. And often that shitposting is focused on conference keynotes done live. Historically, I would do this on Twitter. For those who remember, Twitter's app was not great for building threads, simply because it was easy to lose your place, it was designed for consumption, and I thought there might be a better way. So I built an app specifically in write-only mode to go ahead and write threads called Last Tweet in AWS. It worked super well, but then one day the world's smartest man, self-styled, decided that it was a good idea to buy the platform, kill its API, charge tens of thousands of dollars a month for people who want to use it now, and I realized I didn't want to spend that kind of money to build free content for this jackhole. So I didn't. Instead, I took the application and ported it over to Mastodon, called Last Toot in AWS. So It works. You can visit lasttoot in aws.com, visit it right now, and it will do exactly what you'd think it would. It lives entirely in an omnibus Lambda function fronted by an API gateway. And it was awesome because I built all of this from the beginning with the CDK. I learned JavaScript, however they're pronouncing it these days, or TypeScript, which is the same thing but different. Don't get me started on that mess. Just because the Python version of the CDK wasn't really up to snuff. And frankly, I'm kind of glad I did. Because one thing the CDK made very easy for me was to adapt to changing requirements. Unlike anything else that I'd used in terms of serverless building frameworks and other deployment methods, this just worked almost seamlessly. Switching over to Graviton, for example, was a single line change. It was wild. And this meant it was super easy for me to adapt to continually emerging requirements. And a big one hit one day. That's right, regional latency. So AWS clearly has a whole mess of regions. But it turns out that almost no customers use every AWS region. In practice, they're going to find themselves using anywhere between 1, and often lying about it, to 3, with maybe a workload here or there close to where some developer happens to live because oops-a-doozy and it's difficult to move later. Now, that's normal. Every decision that AWS has made since its inception eschews the idea of having a global control plane. Every region is sort of its own self-contained cloud. If you want to go multi-cloud, go multi-region first, you're going to hit a lot of the same issues. Now, this does have its drawbacks, but they don't get enough credit for its benefits. As of the time that I'm saying these words, there has never been a global AWS network outage. All of its competitors have seen global collapses of various things. AWS has not. Please don't make me a liar on that one. And that's no small thing. But it does mean that it's very difficult to operate across multiple regions simultaneously. And most customers aren't doing this in quite the same way. Because in practice, what happens for customers who are in fact scaled globally is that they have their own customized bespoke deployment system that takes their own needs into account. They'll do canary deployments. They'll do ample testing and look at error rates and the rest. And I don't have time for that on a free app. I'm a lot more reckless because the stakes are inherently low. This isn't banking and we're not saving lives. We're shit posting on the internet. I can break that for 20 minutes if I need to. People pay me nothing. That's okay. Sensible people are not going to approach it this way. And most people being sensible for work, you shouldn't either. But what that meant was that I'm now faced with a challenge of how do I get this across the board deployed to every region? And the reason I needed to do this is because people were complaining about how slow this application was when they weren't, for some strange reason, here in San Francisco talking to Oregon. Instead, they were on the other side of the planet and multiple round trips took an awful lot of time. That wasn't great. It took a whole bunch of work and some very enthusiastic community members' help to get to this point. But I was able to eventually templatize my CDK code to accept parameters, including, most notably, the region I want to deploy it to. Now, the longer you work on something, the more you learn about hidden submarine challenges that you didn't know were lurking there. For me, it was managing secrets. Remember, or learn if you didn't already know, that the CDK renders down, quite simply, into CloudFormation. Now, that's great, but CloudFormation accepts secrets from Secrets Manager, but it won't accept them from Secrets Manager in another region. It barely accepts anything secret from Parameter Store to begin with. So that service was out too. Now, yes, Secrets Manager can replicate secrets cross-region, but that's 40 cents per month per secret times 28 regions, and you start to see the problem. Now, $5 or $6 or whatever it works out to is not the end of the world for me. Truly, it's not. But it starts to seem like a lot of money when it's over 80% of the budget for running the app as I imagined it. And I don't want to spend all that money just on what is very simple from my perspective. Now, you might also point out that AWS App Config is designed for this, and you would be right. It purports to be able to do feature flags and do configuration changes without a deploy. And some of the examples they give include things like database endpoints and credentials. So yeah, perfect. The problem is at the time it was built and I was just rolling this out, it was very focused on coming from EC2 instances, and everything was tied to that. It didn't really have a good story around something that runs simply on a Lambda function behind an API gateway. So it was a non-starter for me. What was I to do? Well, sometimes it seems that the old ways are the best. What I did is I built an S3 bucket in a central region, again, Oregon, and at deploy time, everything doing the deploy for a region can grab from that bucket the credentials it needs because they have very tightly and carefully scoped IAM roles that allow them to do that. That's not an accident, and it shows that it's very easy to out-clever everything because now my cost becomes 0, the complexity is nil, it just grabs a credentials JSON object and stuffs it where it needs to go. Simple. So now I've gotten it deploying effectively to any given region I pointed at. How do I deploy to all of them? Now, yes, a for loop written in Bash would absolutely do this if I just wrap it around a CDK deploy. The problem is that's going to take the better part of an hour because at the moment, AWS has 28 regions that are not GovCloud, mainland China, or some of their secret regions that are all available for customer use. The answer to me lay in GitHub Actions, specifically via their matrix jobs capability. I give it a list of regions written out in God's own language, YAML, and then it just provides that parameter as an environment variable to each job. A failed regional deploy, once you flip a switch, winds up not taking down the entire build, so the regions it works in are fine, and the regions that it didn't work in just throw errors. Great. That sort of takes care of itself. One slight detour that I want to point out is that anything that you do on top of GitHub Actions and doing their builds is free until the free tier runs out, and then it gets really expensive. By my math, every deploy would be something like $1.50, and given that I iterate through things because I don't know how testing works, that could get really expensive. But I'm also not doing this enough to justify having my own dedicated infrastructure for this. So it turned out that the answer to this once again lay down the path of the CDK. Specifically, a consulting company called Cloud Snorkel has built out a framework to run GitHub runners that are self-hosted in your cloud environment, managed via the CDK. And that's awesome. It can have hosted runners that live on EC2, in CodeBuild, in Fargate, in ECS, or most germane to my use case, Lambda. That's right, I'm doing these builds in a Docker image that runs on top of a Lambda function because it's always going to deploy within 15 minutes or something's irretrievably broken, and I don't have to worry about turning things off when I'm done. What this Cloud Snorkel nonsense does is builds an entire state machine on top of step functions that winds up handling the provisioning of this whenever a webhook gets hit. It is set it, forget it, and just works, and its cost is nothing that I have ever noticed, except that it does cost me 80 cents a month in Secrets Manager. I'm willing to pay that once, because I'm not doing this in every region. Just one. This all takes less than 40 lines, and it's kind of impressive the amount of complexity that's abstracted away by this. That's part of the value and also the danger of the CDK, because it gets very difficult sometimes to figure out what's happening underneath the hood. And now, all of this works. If you visit last toot in AWS.com and you check the footer of the page, you're going to see which region is serving your session. All of those regional deployments are given their own ACM managed certificate and then added to a Route 53 latency-based routed record. The closest one to me is US West 1, but your mileage may vary based upon your mileage from other regions. It also helps that this app is completely stateless because all of its data for a session lives in the browser's user storage, and I don't track people or frankly want to know what's going on. And yet, it's not all roses. There are 28 regions available within AWS for deployment. This deployment currently fails on 8 of them, with an inscrutable error the first time you see it, which has since gotten notably better. But what it's telling me is that API Gateway v2, which is their HTTP API version, is not supported in those 8 regions, despite API Gateway itself being there. If I go to the badly designed AWS regional service availability page and click through all 28 regions one by one, and then scroll down to the API gateway section, there's no asterisk or indication that, oh, this one's not fully featured. Similarly, if I go to the API gateway product page, it tells me for regional availability to visit that same useless table and doesn't give any indication that all regions aren't equal. In fact, the only reasonable way to figure out whether or not the service provides something is in a given region is to attempt to deploy it there. The only other way to do this would be to look at all of the what's new announcements from the time a service is launched to a time that a feature is launched, and then the expansion of different features to different regions, and keep a running tally. That's no way to live. Frankly, if I have to deal with that on a common basis, then why wouldn't I just try and build only for the common things that are going to be everywhere, which sounds a lot like the terrible multi-cloud ideas that everyone loves to embrace, but AWS rails against. It's not a terrific plan. Please don't make it that difficult. So speaking of multi-cloud, this app does do a few niceties. It winds up adding alt text to images that I take. And if it detects text, or if it thinks that it's going to contain text based on what it describes, it will attempt to OCR that text for folks who can't view images for one reason or another. It's great for accessibility. Now, there are a bunch of services that'll do things like this, but the one that worked the best when I was building this out without making me make a whole bunch of API calls and string it together myself was, perhaps surprisingly, Azure's Computer Vision API. AWS's recognition isn't up to snuff, at least at the time that this whole thing was built. So yeah, this app does take a dependency on Azure, but it also, unlike too many apps, does not have a hard breaking mode if Azure's unavailable. It will gracefully degrade. It will not do OCR on those images or tell you what's in them, but you can still write threads. This isn't bad for, a free web app. Now, I am a cloud economist. This entire thing cost me less than $10 to run most months. The largest single expense is CloudTrail. And the reason for that is that CloudTrail Lake is awesome, but it also front loads the cost of putting logs into it for 7 years all up front. So it's $2.50 per gigabyte, which sounds obscene, but now keeping logs for the full 7 years is no longer an investment decision. I love the service, I love the model, but it does distort this kind of thing. What's not visible on that graph of cost is that the first month that I deployed this to every region and got it set up, the infrastructure cost was a few bucks, plus another $16 in AWS config charges, because that service has become almost pure rent-seeking on AWS behalf. It winds up charging for multiple times every time you make a configuration change. IAM changes count in every region in which you're active, so that's 28 items for a single IAM change. So whoever's handling the pricing of this thing needs a stern talking to. I digress. Generally speaking, the economics of this thing are great. That's not my problem. But what is? Now, last toot in AWS.com largely just works. But there are some problems with it, starting with the fact that it largely just works. I'm not kidding. Before building this talk, I went 6 months without updating it at all, at which point it became a half-day adventure for me to go through and update to the latest version of the CDK, the latest node version on all of these things, the Lambda runtimes getting current, the deploy system state machine working on its latest version, etc. Say what you will about CloudFormation, and I will say a lot, but a CloudFormation template that you wrote a decade ago will still apply cleanly today. This is less of a concern for most apps that are under constant development that you're iterating on constantly. But for microservice style stuff like this, that once it works, this is a really strange environment. Is this how most people are building applications? Are we so collectively lost in the weeds of continuous delivery and always working on things that there's no point at which we look at something and declare it basically done? Also, what I've built is largely inscrutable to most of the developers I've had look at this thing, because I've retained a couple of contractors to help with the front end work because I am bad at aesthetics. And they don't quite understand a lot of the infrastructure pieces of this. The fact that the CDK infrastructure and the application code share a Git repo is a bit of an anti-pattern to me, but that might just be my own bias coming from the ops world and a potentially disloyal cultist. I'm sure I will be corrected at our next meeting. And lastly, there's no great observability story on this, because if someone has a problem and doesn't tell me about it, it'll show up in the logs when there's an error, but I get to search through 20 distinct CloudWatch log groups, one per region. Yes, I could set up a forwarder to do it. Yes, I could instrument the app with something else to tell me what the username is and then report to some centralized metric database. But I haven't done any of these things because so far it hasn't been an issue. The lesson here is don't overinvest in something when there isn't clear business value for it. I wish more people would take that to heart. So all in all, this was a fun project that I'm sorry doesn't see more use. It was a great way to learn the CDK. I'm a big fan of it. I wish that threads were more of a thing on Mastodon as they were on Twitter. So it's just not something that users need in quite the same way they once needed Twitter authoring tools. For me, though, I just want to say that none of this would have been possible without the greatest feature the CDK has to offer, which is the generous donation of time from the various members in the CDK community, whose reactions upon learning what the hell I was trying to do ranged all the way from, is this guy serious, to, oh my God, I think this guy is serious. Thank you for inviting me into your cult. Enjoy the rest of the talks today.
Nice. Thank you, Cody. That was really, really nice. Hello again, Wojtek. Happy to have you live again, so everybody can see you. I actually have another question, both for you and also for the community joining us live today, because we gave away some prizes with the question, when was the CDK launched? Let's go down the memory lane and tell a story about how did you get started with CDK? What was the year? And just share how you started.
I think I can start with my journey. For me, that was actually when I saw the developer preview version. I believe either that was on Twitter or somewhere on the AWS blog. And that was one of the things I was looking for a long time already. I tried to explore the previous incarnations of different tools like Troposphere and other elements that are having some kind of code related flavor for the infrastructure as code. But when I saw a CDK, something actually clicked. And that was my starting point. Obviously, I didn't start it with a production deployment anywhere near to the developer preview, but I actually started working with it. And back then, I remember that it was JavaScript oriented. And as far as I remember, for the developer preview, there was no Java as well available. So it was JavaScript and Python. And for me, that was JavaScript was the flavor to start. But I heard that you have a funny story to share about your start, Andra. How was that?
It was funny indeed. So Ben is not here anymore, but back in 2019, I used to live way closer to Belgium. I was recently moving from Romania to the Netherlands, taking this amazing job and really diving deep into infrastructure as code and AWS. Before that, I was a telco engineer. I became DevOps engineer and then moved to the Netherlands. I passed out my interview test with the CloudFormation template, thinking this is what I'm gonna do at my actual work. So this was October 2019. The GA was in July, so we already know that. And after I just started my new job, they were like, yeah, we know we have the CloudFormation, but we will switch to this new amazing thing, CDK. So this is how I started to actually work with CDK. I just switched jobs, moved countries, and learned something new.
So that's indeed an interesting story, especially that how it ended. But you said that you started with the GA, so that was one of the things that you done for the project immediately, or you started with experimenting on your own and then you went to the real project?
Yeah, actually, I've started with working on an internal tool, which was meant to be like a wrapper over CDK, because like getting access into the customer's account and being able to actually do the work for the customers, I had to get my solutions architect certificate from AWS. So before I was able to get that certification, I had to do this other type of work. But then I was straight to like customer environments and working with CDK and Python at that time, which was really, really fun. Mostly because I had some amazing colleagues and my manager. They were like full stack developers, really happy to help and also very knowledgeable. So that really helped a lot.
That's indeed a fun story. Cool. So I have actually a question for you, because we have 4 sessions left, at least for this track, obviously, because there is still track 1 running in parallel if you would like to switch sides, but don't do it because that will break our hearts. But I have a question regarding the following 4 sessions. So what session would you like to see the most from all of those 4? I know that it's like picking the favorite, but we need. I'm actually curious which one will be the most interesting for you.
So definitely all of them will be great. But remember at the beginning of the stream, I confessed how I want to try CDKs and learn more about it. So I'm really, really looking forward for the Viktor's session about CDKs. What about you? Which one are you expecting the most?
Well, my heart is still on the data side, so I will choose the AWS Data Ops for CDK. So this one is pretty interesting for me, especially that I think this part is extremely important, and also it would be great to see what is the offering for that particular set of the infrastructure pieces, because as I said, especially that those I have a feeling that those things are need more polish and love in that sense, that we need to have more construct, we need to have more tooling around this, because that will be very, very, very helpful. So I'm looking forward to actually seeing the talk about the AWS data ops for CDK. But speaking about the CDKs, I think we have Viktor with us, because Viktor is joining live. So we can add him to the stage as well.
Let's do that. Hey.
Hello,
hello, dear friends. How are you?
Our Kubernetes guy is here. All good, all good.
Yeah, Kubernetes guy. I like it. I really appreciate that Andrew says that your best session will be my session. Okay, it's a huge pressure on me, but anyway.
Good. So tell us a little bit more about the CDKs. So what were your first impressions when you started working with it?
I will share it during my presentation. But anyway, so when first time I opened CDKs and looked at difference, like how much lines of the code I have to write in CDKs and compare, for example, with YAML, I was surprised. Why so many people like CDKs? Like it's absolutely the same, because I can do almost the same stuff in YAML. But when I figure out about CDKs Plus, I was, wow, it's like new, I don't know, it's new breath in my heart, like started moving like very fast. And now I don't care about a lot of stuff, like, for example, how to manage network policy, how to create persistent storage, how to control, for example, horizontal port autoscaler, all of the stuff. And it's so easier compared, for example, with YAML. So what I'm going to describe just like in a couple of minutes, I was really surprised. Honestly, CDKs in raw, I would say not so impressed me first time, but CDKs Plus, yeah, absolutely.
So obviously there's the most pressing question here that I need to ask. So you are saying that CDKs Plus is actually better than YAML, right?
Yes, yes, you're absolutely right. CDKs plus absolutely better than YAML, because YAML is great. I like YAML because when you ask someone who is from DevOps area and like Andra, we really like YAML because in YAML it's very human readable. You can understand almost everything, but still you have to know the schema, how it works, for example, what is deployment in Kubernetes. You have to understand what's the components, when, how to manage it, and all of the stuff. And for example, again, it's like when I'm speaking about Kubernetes and deployments, in YAML files, you have to provide a lot of information just for Kubernetes because it's how Kubernetes works. It's need for Kubernetes, like for example, label selector or some annotations or something else. And you cannot skip these file lines in your manifest, for example. Yeah, but in CDK Plus, you can just like write one line and say, hey, I want a deployment, and my image will be, I know, Nginx, for example, or my own custom Docker image. That's it, and here we go, and we deploy our application. Yeah, but still, I like YAML. YAML is great, but if you can replace with some better language, I prefer to select TypeScript, Python. Yeah.
Sounds amazing. So yeah, let's, without any further ado, let's give the stage to you. So
yeah, thank you very much. Just to make sure that I am on time, I'm going to put a timer on my watches. So hello everyone and welcome to my session. My name is Viktor. I'm developer advocate as Wojciech, just like what we recently spoke about, do I like YAML or not? And as Wojciech said, one of my favorite topics is Kubernetes. Yeah, I really like Kubernetes. Kubernetes is currently almost everywhere. And today I want to speak with you how you can manage your application inside Kubernetes using CDK. And just like I want to start it from problem, what we currently have in our world. Like, I mean, first of all, why we use Kubernetes? Sorry, why we use Kubernetes? When I ask different customers why they decided to select Kubernetes, one of the reasons is like it's easy to start, quickly deploy, reliability, and it's one of the most popular container management system currently in the world. So Kubernetes, I would say, it's standard de facto when you want to deploy more than one container outside of your local machine. So, and recently read, status, how many Kubernetes instances every organization have. And I was really, really surprised that it's like, if you look at the numbers, like in 2021 and 2022, currently almost 30% of organization has more than 50 Kubernetes cluster. 50 Kubernetes cluster in every organization. It sounds like, wow, why we need so many clusters? But anyway, we have to manage all of them, operation stuff, and how we manage Kubernetes, mostly through the manifest. Manifest created in YAML. YAML is amazing. It's easy for human. It's universal. It's declarative. We can manage very quickly and easy and static. So it's great. But how we start with YAML? With simple things, it's very easy. It's easy to start. Like for example, your first deployment looks like very simple and understandable. But when you need to add more and more complex solutions, like for example, persistent volumes, stateful sets, network policy, RBAC policy, and all of the stuff, it can be really terrible to manage it. And you ask me, hey, okay, Kubernetes is so popular platform. Maybe they have something else rather than only YAML. Yeah, in Kubernetes, if you want to deploy, for example, your application to different environments like staging, production, development, and so on, you can use Kustomize. But Kustomize, again, is based on YAML and provide for you functionality, to manage differential between environments, like, for example, production and staging. And for example, in this screenshot, as you can see, we have a patch for staging and for production for different configurations, like many of replicas, it's our pods, what's the volume, for example, in production, and so on. Another very, very popular, it's Helm. Helm, it's package manager for Kubernetes. And if you're interested in Kubernetes and you want to deploy something in Kubernetes, most probably you will find that Kubernetes provides for you functionality through the Helm, and you can deploy your application. Like, for example, Postgres, you can deploy through the Helm, Redis, Prometheus, just like almost everything you can do it. But again, Helm is based on YAML, and I like YAML, but I prefer to write something in languages, like, for example, in the Go. And in Helm, it's provided for you templates based on the Go. Good start, but still. And what we have from CDK perspective, we have CDKs. And CDK, it's almost the same what we have in CDK. You write your own code, for example, in Python, JavaScript, TypeScript, Java, Go, for example. And at the end, you compile since your code to manifest still in the YAML. You can read it. You can understand what exactly is going to deploy. And this is our workflow. We started with our project, add our packages, since get our manifest, and through the other method, like, for example, through the kubectl or GitOps, if you already apply, for example, like Argo CD or something else, you deploy this manifest to your Kubernetes. Your Kubernetes can be everywhere. It's not only about AWS, it can be deployed to everywhere. So, sounds good, but if you look at the nutshell, like how it looks like CDKs, like when I first time look at this screenshot and this, like the code from left side, we have CDKs, from right side, it's my YAML. So the amount of lines like almost the same. So why have to select CDKs? And one of the reasons, because we can look at CDKs plus. And, many of these lines is important only for Kubernetes, not for us as developers. And just like I can strike all of the slides, for example, do we need a metadata like name Nginx? No. Do we need template labels Nginx? Again, no. Do we need selector? Again, no. So for me, as for developer, only one line is important, and it's image Nginx. And through the CDKs plus, you can say, hey, I'm going to deploy my application, and my application will be based on image Nginx. Great. And that's how we can start it. So let's create some application, just like we like to do some like demo and so on. And what will be as my application? I'm going to create very, very simple application. It will be two-tier application like web layer, cache, of course, because I want to store some in-cache data from my data layer. And the first requirement for me, it will be high availability. So it means like I will need to have 2 instances of web, 2 instances of cache, and 2 instances of database. I cannot put all of these pods, for example, in one instance on one node. If you're familiar with Kubernetes, like you can deploy application, and this application for some reason can be deployed to one node. So I just decided to say, hey, first of all, I need to split between web and cache layer and my web layer and DB layer, sorry, and also to make sure that web and cache very close to each other, because web and cache is going to communicate very frequently, and I want to avoid latency, network latency. Also, I want to expose my application, like for web, it will be through the load balancer, it should be available outside, like externally. And of course, cache, it will be internal only inside of my Kubernetes, like cluster LP. And the last one, it's related to the network isolation. We know in Kubernetes, you have namespaces, but namespaces, it's only logical isolation. It's not provided for you some physical isolation, like, for example, network isolation. For that reason, you have to create your own network policy to define who and how can communicate with each other. For example, in my case, web can communicate with cache can communicate only with data layer, but I cannot communicate from web, for example, to DB layer. For me, it's very important. So let's do it. And I will be very honest with you. I make a recording of this code because, I'm not type so fast as we have only 20 minutes. But anyway, so I'm currently in my Kubernetes CDKs projects. And of course, from what start I'm going to do. So first of all, for me, it's very important to define where I'm going to deploy my different layers. Like storage layer, of course, it should be on storage instances. Let's say it will be labeled storage optimized. For web layer and cache, maybe I would prefer to select memory optimized, because for me, it's not so important about storage. For me, it's more important about the memory. So in the first line, I defined it construct about storage optimized labeled. And in the second one, I'm going to say almost the same stuff, but it's magic currently will be happened. As you can see, Code Whisperer suggested for me something. And here we go. He said, hey, I decided maybe you need to say to create the same stuff, but only for memory optimized. Looks good. So let's continue. So the next one, it will be my data layer. In data layer, I'm going to use stateful set. I'm not going currently deep dive and explain what's the difference between deployments and stateful set. If you prefer, you can contact with me and we continue this conversation. So anyway, for stateful set, I am going to define what exactly I'm going to deploy. It will be my containers. For containers, of course, I have to define my image. Let's say it will be my DB image, doesn't matter currently, and port number, like, I know, 9000 port, for example, yeah? And also, I do remember that my requirements, that's it should be highly available, replicas to at least two instances. I want to spread, make sure that I am not put all eggs in one basket. So I said spread true, and isolate. Isolate means like a great isolation from network perspective. And from scheduling, I want to attract it, make sure that I put this data layer inside of my storage instances. So it's how it looks like DB layer, like database layer in CDK. And when I say, hey, in scheduling, it's storage node, it's created affinity, not affinity inside in my Kubernetes manifests. And also when I say spread true, it's for me created port anti-affinity and requirements during the scheduling to make sure that I spread these ports between different nodes. Okay, we continue with cache layer. For cache, it will be deployment. Again, like it will be almost the same stuff. And as you can see, Code Whisperer a little bit helped me. So it's image, of course, cache, port number, for example, 7000. And I also have to define how I'm going to communicate with my DB layer. Like I need to define my DB host and DB port. Code Whisperer helped me, but not so good. I want to say to string to make sure like I have the right configuration. And the last one, of course, again, just like replicas to spread, of course, true, because we remember high availability requirement, and isolate also true. So almost all of these lines, Code Whisperer helped me to write. Not maybe so good support, like, for example, if I say, hey, please write me for me deployment, no, but based on the context, which I already written earlier, so it helped me to write and speed up this process of this, how I write my CDKs. So scheduling, again, memory nodes. And we remember that for memory nodes, it's another one. So environment variable where I define, it's how it transformed to YAML configuration, to YAML manifest, where I define my environment variable for DB host and for ports. And also for scheduling, again, not affinity, not selector, memory optimized. So it's where I'm going to deploy this application. So let's move on. And the last part for me, of course, it will be now, before to the last part, of course, I have to create and expose my service, cache service. Because as you remember, I'm going to have two different services, one of them for the cache, another one for web layer. From service perspective, it's created for me cluster IP. From Kubernetes perspective, it means like only internal services, and I can communicate only internal inside of my Kubernetes cluster. And let's back. The last part, of course, it's related to web layer. And Code Whisperer understand, hey, you definitely need to deploy your web layer and help me to define all of these lines of code, like environment variable, also supported me to write what's the cache host, cache port, all of this stuff. So the final part, of course, is related to define replicas, spread, and isolate. Again, because we remember from my requirements, I have to make sure that I put different port and different nodes. And the last one is related to scheduling, attract with memory nodes. And also, if you remember from my slides, I said web layer and cache should be very, very close. For that reason, I defined collocate with the cache. And also, I want to say who and how can communicate with each other. So we said isolated, like web layer, cache layer, DB layer, but we didn't define that, for example, web layer can communicate it with cache layer. And through this construct, like web connection allowed to cache, it helped me to create the network policy. So as a developer, I just like write one line, and from a manifest perspective, it looks like in this way, where ingress, port selector, port selector, again, who and how can communicate with different layers in my application. So, and the last part of this demo, it will be to create, of course, expose my web layer, because the web layer is going to be my load balancer. Let's do it. So web layer to expose via service, and via service it will be my load balancer. What does it mean like load balancer? It will create separate load balancer inside, for example, in AWS, and support it and provide it for me external access, like for example, from everywhere, like from the internet. So I defined my load balancer, and let's look how it looks like in YAML configuration. Just in 1 second. Yeah, here we go. So expose via service, and we see like it's load balancer. So it's how quickly and easy I can write in CDKs plus my application. And if you ask me what will the next, of course, I'm going to sync this application and show you how many lines it will be in YAML. And for example, just imagine that you need to repeat the same stuff for 50 Kubernetes in other clusters. So it sounds like you need to do like a lot of copy paste from YAML perspective, but from CDKs and CDKs plus especially, you can write a couple lines and transform it to like 400 lines in YAML. So as you can see, it demonstrates that we have all description like network policy, services, load balancer, and almost 400 lines, and which were written only 20-25 lines code from CDKs. Okay, sorry, but our requirements is not finished. We understand like web layer and cache layer can be scalable very easy, and we say, hey, we want to scale our application from horizontal perspective. Inside in Kubernetes cluster, we are going to install Carpenter as a cluster scaler. It's very great cluster scaler. If you're not familiar, I highly recommend, and can help you save a lot of money. But how we can install Carpenter? Carpenter currently distributed through the Helm. Helm, as you remember, is package manager inside the Kubernetes cluster. And there is a question, should we rewrite Helm package from Helm to CDK, for example? And how we can install, for example, Carpenter? No, my answer no, because CDKs supported natively Helm chart, and in CDKs you can define a construct and say, hey, I want to deploy my Carpenter inside to my Kubernetes cluster. My charts will be placed here, my version of these charts, like for example 30, and values for my charts defined in section of values. What about horizontal port of the scaler? Just like, of course, first of all, what I should do, I have to delete amount of replica from my web layer and, for example, from cache layer, and move it to horizontal port of the scaler construct and say, hey, in my case, it will be minimum replicas 2, maximum, for example, 100, and utilization 80% of CPU load, blah, 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 all of this stuff. Again, couple lines in CDKs plus help me to create horizontal port of the scaler object inside in my Kubernetes cluster. That's it. I hope you enjoy my session. If you want to repeat by yourself this demo, you can find code sample using this QR code, and enjoy other sessions on CDK dates. Have a good day. Bye-bye.
Thank you so much, Viktor. That was an outstanding explanation, and also very brief, a very good presentation how brief the code was and actually how much YAML it was generated. I really, really like that. So there is a hope for everybody that it's struggling and with this labor, being a YAML engineer, that you can actually use CDKs and become an engineer that uses the programming language in this way. That's a good one. That's a good one. Thank you very much.
Thank you too. And I hope you enjoy. So currently you see how you can use CDKs plus especially and transform your writing YAML files, like 400 lines of YAML, just to 25 lines of codes in CDKs plus.
Yeah, exactly. And this is the best thing you've presented is actually about the reusability part, because you've made a very right point that assuming that many organizations have multiple, more than dozens of those clusters, they need to actually pay attention how to make this maintainable. So this is actually a very, very valid point. Thank you so much. We have almost another session going on because we are right on time. Next session is actually, I have a pleasure of introducing a colleague of mine, Maciej Radzikowski. We've met a few times. Last time on the AWS Community Day in Warsaw. Maciej presented there with a different presentation, but now he will talk about the CDK pipelines for serverless and going beyond that. So this is pretty interesting topic. Thanks again to the amazing ASL interpreters that are helping us. And let's start another session by Maciej.
Hello, I'm Maciej, and I would like to talk about CDK pipelines and how we adjusted them for the needs of our serverless projects. Few words about me. I'm developer and architect building serverless solutions on AWS. I work for Merapar, which provides services for media companies. So I had opportunity to work for the clients like Sky UK, NBC Universal, or Liberty Latin America. Apart from that, I'm AWS community builder, and I write about serverless on my blog and on Twitter. What I will be talking about is firstly why we choose Code Pipeline as our CI/CD solution, and then what Code Pipeline offers and what we need, which isn't one-to-one match, and finally how we came with our opinionated CDK pipeline and open source library for CI/CD. So, why Code Pipeline? As you may know, Code Pipeline probably isn't the best CI/CD solution in the world. There are some drawbacks of using it. The code build, which is used for any computation that you need in your pipeline, can have quite long provisioning time. Code Pipeline is more complex to set up than some alternatives like GitHub Actions. That's my opinion, but I saw multiple people share this opinion. Code Pipeline does not offer built-in notifications for the commit build status, for example. So you know this little green circle next to your commit hash that tells you that the build of this commit succeeded, or Slack notifications if something went wrong, if the build failed. It also doesn't offer a built-in solution for the pull request or feature branch deployments. There is a pattern that you can apply with the new code pipeline dynamically created for each new branch that you want to deploy. Although this isn't really a solution that I like, because in addition to the pipeline build time, to CloudFormation deployment time, you add time for provision a new pipeline each time you create new branch. However, there are some benefits of using Code Pipeline, and the biggest one is there are no external integrations for your CI/CD. So you keep everything in AWS. That's nice from the security standpoint, because since this is already in AWS, it uses IAM permissions like everything else, and your CI/CD needs quite broad permissions to deploy all the services that you need. So you don't have to give this broad access to any external system like GitHub Actions, for example. Of course, you can safely create connection between GitHub Actions and AWS to allow deployments. However, keeping everything in AWS reduces the attack surface. And secondly, since we are already building on AWS, using Code Pipeline does not require additional approvals from the corporate. Because if we build for different customers and we want to use some external system that customer is not already using, so if you would like to have the CI/CD on GitHub Actions and the customer is still using the good old Jenkins, the path to get new external tool approved to use in large corporation can be a months-long path without any guarantee of success. So if you are already on AWS, we need no approval to use code pipeline for our CI/CD. And lastly, since it's already on AWS, there is no separate billing, so there is no financial department that would need to approve and pay for invoices. The customer will receive the same invoice from AWS for the AWS account as always, maybe with a few more cents or dollars for our CI/CD. And since, like I said, we build for different customers that use different tools, some use GitHub, some use Bitbucket, and so on. Some use Jenkins for the CI/CD, some use GitHub Actions, all kinds of services. If we keep what we need on AWS, when we came to to create some project for the customer to build some solution, if we always use code pipeline, we have the same CI/CD solution in each project. And we don't have to start the project with solving how to set up CI/CD on this particular system, because we already have the good solution. But like I said, the setup can be quite complex. To fill the gap, to have those missing features like commit build status and Slack notifications, you need to provision additional resources next to the code pipeline. So starting new project with creating not only code pipeline, but also a bunch of other things is not fun and takes time. So here comes CDK. We can put everything, this whole complexity in a single CDK construct that will be easy to use, and we can have CI/CD in barely few minutes for any new project. So what code pipeline can actually do for us, and what we in our serverless projects require from the CI/CD solution. So from the benefits, what code pipeline provides, it can start build on Git commit. So whenever we push a new commit to the repository, it can build virtually any project, because with using code build as the build container, we can build basically anything. Code pipeline can deploy CloudFormation stacks, which is nice since we are using CDK. It can deploy to multiple environments on multiple accounts, and we can run post-deployment tests again with code build. However, we need few more things in our projects. We want to be able to deploy feature branch environments. Those ephemeral environments are created each time we create new branch, and are deleted when we delete the branch, when we merge it to the main. And on each feature branch, we run the test suite. So in the pull request, for example, we know that, okay, those changes built successfully, deployed successfully, and all the tests, both unit and integration tests, run successfully. Also, we want our developers to be able to deploy their own environments from the CLI. With serverless, we can deploy basically as much environments as we want, with basically zero costs for them unless they are used. Yeah, so we want our developers to have their own environments on which they can develop and test new features. And we want those notifications that I mentioned already, commit build status notifications to repository, and deployment failure notifications, for example, to our Slack channel. Also, with code pipeline, we encounter some problems with connecting to external repository to the GitHub or Bitbucket. With Bitbucket, the connection method does not limit permissions to a single repository. Instead, it gives access to the whole organization, to all repositories in the organization, which is not great from the security point of view, and also probably won't be approved by any of our clients. Also, we can subscribe to different events from the repository, like to trigger actions on the new commit, on the new branch, but we cannot subscribe to the branch deletion event. So if we create a ephemeral environment, we also want to be able to automatically delete it. There is some solution because we can subscribe to the pull request merge event. However, if some branch is created and there is never a pull request for it, because, for example, branch is deleted as no longer needed, we don't get information back to our CI/CD, and this environment is left forever until we manually delete it. So for all those problems and for all those missing features in the code pipeline, we came with our library, the opinionated CDK pipeline. If you look in the CDK pipelines documentation, the CDK pipelines is the CI/CD that is built in the CDK. They already write that CDK pipelines is opinionated construct library. So we can say our library is even more opinionated. The goals that we set is to have the library, the CI/CD that the library provisions to build on top of the CDK pipelines, because CDK pipelines already use the AWS code pipeline. They already solved how to build and upload all the artifacts and how to deploy to different accounts. So we don't want to reinvent the wheel. There's also the deployment, the CI self-mutating, which is also nice. We never need to manually deploy the CI. If we make some changes, it's automatically updated. We want CI to be customizable in terms of the build and deployment steps, because each project is a little bit different, and we want to deploy with different build steps, with different test scripts, and to different environments, different accounts, different number of external accounts, and so on. We want to have easy integration with GitHub and Bitbucket that also don't give too broad permissions to other repositories. We want to have those feature branch deployments to ephemeral environments. We want developers to be able to deploy their own environments from the local CLI, which isn't by default supported by the CDK pipelines. And we want to have those notifications back to repository with the build status and to Slack if the build fails. The solution is the construct CDK application, which extends the CDK app. So the first construct that you define at top of the CDK entry point script. We mirror the source repository, the GitHub or Bitbucket repository, to code commit, because it turns out you can subscribe to all kinds of events from code commit. So you can subscribe to the branch deletion event from the code commit. And by doing the mirroring ourselves, we solve the permission issue. We use code pipeline for the main branch deployments, where we deploy to multiple environments, to multiple accounts. But for the feature branch deployments, when we create a new branch, since this is just building and deploying one environment, we use a code build project instead of running the whole code pipeline. And finally, for sending notifications to GitHub Bitbucket with the build status, we have Lambda that subscribes to the events from code pipeline and code build and makes API call to GitHub or Bitbucket. And we use AWS Chatbot for Slack notifications. This is how it looks like in terms of deployments. So we have our external repository that we mirror. This mirroring is part of the library. You basically provide the repository name and access credentials, and the mirroring is set up for you. So the mirror is to code commit, and on the main branch commits, we run the code pipeline, which deploys multiple environments, runs all the unit integration tests, and so on. And for the commits for all other branches, we run code build project that builds and deploys this single environment using the branch name as the environment name. And when branch is deleted, we trigger another code build project that deletes the environment. And also, we can deploy the environment from the local CLI, so each developer can create their own development environment, typically using their name as the environment name. In terms of notifications, like I said, we have Lambda functions that subscribe to code pipeline and code build project, and they make API call to GitHub or Bitbucket, setting the commit build status as in progress, succeeded, or failed. And also on failures, we send failures to Chatbot, which sends nice and readable notifications to our Slack channel. Well, no build failure notification is nice, but at least it's readable in our Slack. And finally, the accounts. Typically, we use a single development account where we have the CI pipeline and where we deploy the ephemeral environments for the feature branches, and also the developers can deploy their own environments. And then we have separate environments for the staging and production account. However, the other common pattern is to have single account just for the tooling, so just for the CI pipeline, and then have other account for ephemeral branch environments or development environments. This is also possible and configurable. You can define where each environment should be deployed to what account. So, how it looks like in the code, I would say quite simple. You create CDK application where you provide the function that defines your stacks, and those stacks will be deployed to in all cases. So from the main branch to all the environments, from the feature branches for the ephemeral environments, and from the CLI for development environments. You provide the repository details, so GitHub or Bitbucket and the repository name. Separately, you provide access credentials in the SSM parameters, and then you provide the pipeline definition where you provide for the main branch what environments should be deployed, and you can provide additional pre and post scripts. So in this case, for example, we deploy the test environment, and after the deployment, we run integration tests. Or, well, in this case, we write about running integration tests. And then, if that succeeds, we continue and deploy to the production. Where each environment is deployed, you can define in the CDK JSON. So there you define that, okay, so for the test environment, deploy to this account to this region, for the prod deploy to this account, and so on. This is nice because you can also define additional parameters for each environment, like for example API endpoints and so on. So the things that differ from environment to environment. so you can keep your all the configuration per environment in a single place in the SDK JSON configuration. For the missing features in the whole solution, probably the biggest is queuing the feature branch deployments. So there is the possibility that if you push to a branch, the code build project starts with the deployment. If you quickly after push another commit to the same branch, another code build project will start, but it will fail because it will try to update the same CloudFormation stacks that are already being deployed from the previous commit. So that's something called the radar to improve. From the main branch, there's no such problem because code pipeline has this benefit that it already queue the builds. Okay, thank you for listening. More on serverless available on my blog and Twitter. The project Opinionated CI pipeline is open source on GitHub. The CDK construct is available for the Node and Python. I encourage you to try it out. Maybe that's something that will improve your CI/CD in the next project. This presentation is also available. You have the link here and QR code that also leads to the presentation. Thank you.
Thank you so much, Maciej. That was a very interesting presentation, especially from the standpoint how to use CDK pipelines in such interesting scale. So we are already preparing for the next presentation. In the previous segment, I told Andra that this is the most interesting one for me. Obviously, all of them were very interesting and will be very interesting, but I'm waiting for this one because, as I said, data is on my heart is on the data side still. So I would like to introduce Lucas that will join us and present. And today we also have Anmol that will be available in the comments section and waiting for the comments to answer. So Anmol, if you are hearing us, let us know in the chat. And yeah, Lucas, without further ado, let's start the next section. Stage is yours.
Yeah, sounds good. Thank you so much. Hi, everyone. So today I'm just going to take some time to go over a library, a CDK library that we built called the Data Ops Development Kit, also abbreviated as the DDK. I'll give some background, some examples, and talk about where the project is going. So a little background on me. I work within AWS Professional Services. I focus on some of our open source tools. And one of them is the DDK, which is the focus of the presentation today. So again, I'll give you a little bit of an intro and a history on how this tool, was birthed and why we created it. Sort of an overview and a background of the DDK and sort of the value it adds to people managing their infrastructure on AWS with the CDK. I'll walk through some examples, and then I have some sort of basic, entry-level links and how to start contributing or at least getting involved with the project and using it in your own environments. So first on the background, when we initially started thinking about building these tools, these were some of the problems we wanted to solve. Things like, repeatability for data and analytics workloads in AWS and data lakes and data pipelines. We wanted to cater towards data engineers who wanted to focus their time on building, business logic for data lakes and data pipelines, as opposed to, focusing on all the configuration that goes into, the infrastructure management side of things, the DevOps side of things, et cetera. And then we also wanted to obviously accelerate delivery, give people a quicker way to build out their use cases and data pipelines without sort of the as much of a learning curve as far as the CDK goes into building more complex pipelines. So a little background and a little history here. The DDK, Data Ops Development Kit, is an open source library of CDK constructs. It was initially released in early 2022, so it's about getting close to about 2 years old. We started with 0.10. We're now, I think, at 1.20. So we've had one major version release since the initial release. And again, it's a library for the CDK. So we include things like resource factories, data stages, and data pipeline constructs, which I'll go into a little bit more detail on in the next slides. So quickly, as far as I don't know why I lost the. I may have lost my icons here. I'll try to proceed and explain this the best I can. But so building a data workflow in the cloud can look simple as far as an architecture diagram, right? We may have some place where we want to set up our storage, right? That could be an S3 bucket. In the example I was going to show is an S3 bucket, right? We have some event, right? Some data gets put to that bucket, all right? And then we want to, route it somewhere and do something. So in this example, right, we want to set up a SQS queue, for example, and we want to run some, business logic against this event, right? This data, essentially. So the reality of setting up a data workflow in that in AWS like this also includes a bunch of things you may not think about, right off the bat when thinking about setting up your data pipelines, right? There's things like logging, monitoring, alerts. There is, IAM, right? All of our permissions, keeping things least privilege. How do I do that with the combination of resource-based policies, IAM policies, et cetera. There is sort of the DevOps side of things, right? There's how do I, deploy my data pipelines and all my data infrastructure with sort of CI/CD, GitOps, et cetera. And there's also sort of the event-based and scheduling aspect to our data, right? How are we triggering our data pipelines? How do they flow through all of our various components in our infrastructure, and how do we route things between services? So the DDK intends to accelerate delivery on sort of this border here. And again, apologies for not having the icons show up. I don't know what happened here, but essentially, on the left-hand side, we have an S3 bucket and a CloudWatch event and a queue and a Lambda function that would run some business logic, right? And our intention with the DDK is, okay, well, we want customers to be able to focus on the business logic, right? And we want people to be able to build out constructs on top of the DDK, right, or within the DDK, to allow the broader organization or a broader team that's focused on the data engineering to focus on the business logic, right? Have repeatable constructs for our data pipelines, our data lakes, and then plug in our business logic as needed, as well as also allowing for production DevOps ready use cases where we're deploying to multiple environments and multiple accounts. So the DDK really sort of does a good job of providing some of these things out of the box, and I'll show you that in a little bit. So I wanted to quickly walk through some code snippets of what the DDK looks like in CDK programming language. Before I go into it, right now we support Python and TypeScript. So the DDK is all written in TypeScript, and we use JSII to package it into both NPM and PyPy. So we have both public registries that host versions of the DDK that are both in TypeScript and Python. So your preferred language of choice out of those two is available today. This first example here is a very simple example of a data stage. So one of our main components in the DDK is data stages, and data stages are essentially, one or more services, right? An L3 construct built on top of CDK L2 constructs that take data from point A to point B typically. So in this example here, I'm using a stage called the SQS to Lambda stage. What that's doing under the hood is it's creating a queue for you, it's creating a Lambda function for you, and then routing events from a queue to a Lambda function. Now, we have a handful of stages. I think we have 11 to 12. I wanted to quickly mention that this is sort of what we provide out of the box, and we're continually adding more stages as we do development and work on the roadmap, etc. But there's always the ability to add your own custom stages. We're not saying here that you have to use all of our stages, and that's all that's available, right? The DDK is intended to be sort of a framework as well, where you can plug in your own stages. The other thing to mention about data stages is we do have sort of like an escape hatch functionality built into our data stages, which essentially means you can bring your own bucket, bring your own function, right? So most of the infrastructure pieces in a data stage allow you to either, let the construct build, fresh infrastructure for you, or you can create it somewhere else and plug it into the stages. So this is probably our most important construct that we offer. So this is an abbreviated snippet here, but the data pipeline construct is a construct that allows us to route stages together using Event Bridge. So in this example, I have a Firehose to S3 stage. That's creating a Firehose delivery stream, right, which delivers data to an S3 bucket. And then in the lower stage here, in the third line, we have that SQS to Lambda stage I showed you. So what I want to do here is I want events that come through my delivery stream and are delivered to S3. I want them to then be routed to an SQS queue, and I want the Lambda function to run some business logic and do something with it. So what the data pipeline construct does under the hood is it basically does event rule mapping. So for each of our data stages, we have an input and an output. So that input would be sort of our event target. And in this case, if you look at the second stage in the data pipeline, right, we have an SQS to Lambda stage. So in that case, our event target would be an SQS queue. And on the output side, we have an event pattern. And that CloudWatch event pattern would look for whatever happens at the end of that stage that we can then route to the succeeding event target. So in this case, what the data pipeline construct would do is it would look for in our stage for an event pattern that's defined within that stage. In this case, we would have an S3 put object, maybe to some prefix, as well as the bucket, the destination bucket. And then the event target would be the SQS queue defined in this stage. So what the data pipeline would do in this case is it would set up an event-based rule to look for S3 put objects to the bucket and prefix defined in that stage. And then it would have an event target to that SQS queue. So if we deployed this using the CDK, we would end up with essentially a small data pipeline, right, from Firehose all the way to Lambda. The other construct I want to talk about a little bit is the CI/CD pipeline stack construct. So maybe I'll bring the attention towards the right here. So this is what the CI/CD pipeline stack construct looks like in action. It's similar. It's built off of the CDK library's pipelines submodule. So there's a construct in there called code pipeline. So this is sort of a opinionated version of that. And what we have in here is the ability to sort of define a pipeline, right? So we add a source action, which is, in this case from a code commit repository where all of our CDK code would be. We have, a synth action that would, generate all of our CloudFormation templates under the hood using CDK synth. And then on the bottom here, we have this add stage method on this construct. So what that does is it essentially adds a deployment action to that CI/CD pipeline. And then within that deployment action, you're defining sort of an ID, right? So that could be your environment. It's just a name. And then it would also define a stage, right? So the stage is just looking for a generic and CDK native stage construct, right? Which is essentially could be a wrapper around a stack or set of stacks. So in this case, what we're doing is we're defining an application stage, and we are building a stack within that stage. And then we can build whatever, data pipeline we want. We can use the DDK, we can use the CDK, it's interchangeable. We can use both. And then in the CI/CD pipeline construct, we are just instantiating an application stage per each of our environments. So where this gets more interesting is we can also do configuration for our environments that are specific to maybe dev and prod. So that kind of segues into this configurator construct. Again, this is a take it or leave it sort of construct. It's not nothing in the DDK is mandatory that you don't have to use any of our constructs, but we do provide sort of a config construct that can be a really good starting place, or a tool if you don't want to build out your own configuration mechanisms. But essentially what the configurator can do is it can define in a JSON or YAML file all of your different configurations across the environments. So in this example, I'll kind of breeze through it because we're running out of time, but we have a dev and a prod environment, and within those environments, I want to define resource specific property settings. So I can do that in two ways. At the top, you'll see not the top, but within the dev environment and the resources configuration, there's an AWS ::lambda function. That is a sort of specific to anything in dev that is a lambda function of that resource type will be set with the following properties. So in this case, I want my memory size in dev to always be 128, and I want my runtime to be Python 3.9. And then in my prod environment, I can do 1024 of memory size, or I could do a different runtime if I want. You'd probably not be doing that. And then the other example is a very explicit ID-based configuration. So in the next example, you'd see a dev stage /queue. So in my dev stage, there'd be a queue created, and that with a construct ID of queue, and then I can set explicitly that I want its visibility timeout to be 180. So that's kind of how the configurator works. The other things you can do there quickly, set removal policies for the environment. Maybe in dev, we want to be destroying things like S3 buckets and databases, et cetera. And then also add tags specific for the environment. And then on sort of the CDK code side of it, the configurator construct allows you to pass in this case, this example is taking self, right, from wherever it's within, but it can take any scope. So it can take an app, a CDK app, it can take a CDK stack, or it can take a CDK stage. And the configurator will apply to anything within those scopes. So at the stack level, the app level, or the stage level. You can pass in the ddk.json here, which is my JSON file. You can pass in any path, right? Any YAML or JSON path. And then my environment, right? So I want to set this for dev or set this for prod. So within each environment, I can define, okay, I want you to pull from this configuration, use this configuration to override any of my resource properties within that scope. So quickly, before we run out of time, we have a bunch of open source DDK patterns. Those are hosted in a GitHub repo called AWS CDK examples. So I'd encourage you to go check those out. Those are kind of like our real world sort of examples that contributors and we have developed to sort of show you what this looks like in the real world. And then, quickly how to contribute and get involved. In our docs, we have a getting started workshop, which is a very great place to start. We also have a serverless data lake workshop, which is more of a full-fledged data lake using the DDK. Check out the source code documentation, and then we also have a contributing guide if you want to get involved and start, helping us define the roadmap. And then always support us with a star on the GitHub repo if you get there. So that's it. Thank you so much for listening. And hope to see some of you in GitHub soon.
Thank you so much, Lucas. That was very interesting. I'm definitely leaving a star because that's one of the most interesting things for me. Also, thank you, Animal, for helping us on the chat. I would love to see more of those DDK examples. Can community members, can they contribute to the DDK examples repo with another constructs and patterns that you explained?
Yeah, absolutely. And that's highly encouraged, as well as the core library. So we highly encourage contributions from everywhere. So please take a look and get involved and open an issue if you have a question, etc. So
thank you so much. Sounds great. All right. We do have our next guest. I will do my best to not butcher your name, Jabril. I hope I pronounced it correctly. Are you with us?
Yes.
I can see you and I can hear you. That's great. I hope I didn't.
Cool.
I pronounced correctly your name. With us is Jabril Oyetunji, and with very interesting title and the presentation about a skeptic's guide to Terraform CDK adoption. So without further ado, stage is yours, Jabril.
All right. Hello, everyone. My name is Jabril Oyetunji, and welcome to this session titled "A Skeptic's Guide to Terraform CDK Adoption." So first off, who am I? Like I said, I'm Jabril Oyetunji. I'm a software engineer interested in all things cloud native. Also, tech and again speaking or the X or Twitter, whatever it's called these days. All right then. So before we begin, I'd like to say a bit about the agenda. First, I'll be going over why, the road to adoption, and the key takeaways. So not too much to cover, but I think it's concise enough. So before I begin, I'm just going to go a little bit over how skeptical I am. So before now, I've written to Terraform providers. At this point,
unfortunately, we have some technical issues. I hope Jabril will be with us soon, and he will be able to finish. In the meantime, Andra joined us.
Yeah. Hi again.
Hi again. So let's talk a little bit more about the upcoming sessions on the track one. What do you think about the upcoming ones, especially about I think you've mentioned that this will be a keynote, right? Because the last ones are actually keynotes on the first track. Can you tell us a little bit more about the session that will be the main one, the keynote at the end, about contribution to CDK?
Sure. So This year, as I mentioned, we are turning things around. So we have Kendra Neil from the CDK team joining the track 1. So after we finish everything on this track, we welcome everybody on track 1 to watch very interesting talk about how you can contribute to the CDK. And I'm sure there will be some very good announcements and sneak peeks. Yeah.
I looked in the back because we have Jabril with us again. So let's give another chance to Jabril to reassume and resume the presentation. So I will add you to the stage. And yeah, let's do it once again. No worries.
Yeah. All right. So again, I was just going over how skeptical I am. So at this point, I've written 2 Terraform providers, over 7K lines of Terraform. Not much, but I've done enough that I really like using Terraform on a day-to-day basis. I once made a bank transfer using Terraform. It was the second provider I built. So yeah, needless to say, I really like Terraform. So Terraform CDK. What? So one of the reasons why I wanted to try it is because sharing technologies are fun, and it's this new thing that I'm not sure of. So yeah, why not? I've also used Pulumi in the past, and it was a nice experience. And the third is like, what's the worst that could happen?
I guess that's the beauty of the technology nowadays, that we need to face such turbulent issues. So giving again a little bit more time to Jabril to resume and go back. You've mentioned that we have at the keynote we will have the explanation about how to contribute, but can we expect something more about what are the plans, what are the roadmaps, what will be more something that would be more interesting to actually listen to the L2 or L3 constructs that will be available?
Yeah, I honestly don't know exactly what will there be, but I am expecting something around like prioritizing and yeah, because everybody's contributing to CDK, there are a lot of contributions being made. I'm sure Kendra is like doing a great job prioritizing and organizing the roadmaps. So I hope to see something on that side, but let's just stay for the keynote and find out. Yeah.
So we have approximately 13 minutes to keynote. We do have Jabril with us. Let's invite him on stage and ask him if he will be comfortable to deliver this in 30 minutes. Otherwise, maybe we can actually record this and then upload later to the YouTube channel. Hello, Jabril. Do you hear us?
Hey, yeah, I do.
Right. We will have 13 minutes until the end of the time. So if you feel comfortable, we don't want to rush you, but if you feel comfortable, please continue. But if not, we can always record this session and then upload it on the YouTube channel as well. So that would be another save for you. So if you would like to continue,
right,
floor is yours.
Yeah. Feel free to choose.
Anyways. I think I'm good to continue.
Okay. So yeah, please continue.
So yeah. So the road to adoption. Step 1 was to find an excuse to experiment. So when experimenting, one of the things I had in mind was to find a small project that had a clear goal. The second was small enough that I don't get overwhelmed. And third, it should feel rewarding by the end of it. Step 2 was to keep an open mind and recognizing that things wouldn't always translate the same when using new technologies. But I was always focused on the end goal. So the plan for me was simple. I run a Raspberry Pi on my home network. So if I could take a pre-built Docker image that I wrote myself, write some CDK for Terraform, and deploy this to my Raspberry Pi, mission accomplished. So step 3 was to execute, which I did. Using the Terraform CDK documentation, I was able to use the Docker provider for CDK to deploy a pre-built image I had to my Raspberry Pi. So does this mean friendship ended with HCL and CDK is now my best friend? Well, no, but I learned some very interesting things. First was when learning or embracing new technologies is to develop a structured approach, like I did here. Second is it's not as bad as you think. Before now, I had always wondered why I'd need that. However, embracing these new technologies isn't as bad as it seems. And again, it's always good to keep embrace an open-minded approach for infrastructure management. And the final point is I get to keep HCL. Well, kind of. As far as I know, you can generate some HCL from the CDK Terraform provider, but I'm not sure. So I'm keeping that in the back of my mind in case I ever really need it. And with that, thank you very much for attending my talk. And you can find me on the interwebs at Syntax Error, and my email is also there.
All right, thank you, Jabril. Having you still on call, can you tell us a little bit more about those Terraform providers you wrote? What was your experience and what are you looking for when switching to CDK, actually? And we lost Jabril again. So
yeah.
Unfortunately, we will try to wait for him if he will join to answer the question. If not, I think we have 9 minutes to wrap up before the keynote. So we can start wrapping up and maybe Jabril will join. So yeah, for the closing notes, I would like to first thank you for the amazing support that we had for the speakers. Thanks to all people that actually contributed to this event, speaking and recording those sessions. We would like to thank you, the audience, because without you, there will be no such great event, for your engagement, comments, and everything that you shared with us on the chat, including participation in the quiz. And obviously, we would like to thank all people involved, organizers, co-hosts, amazing ASL interpreters that are helping us on those sessions. So thank you so much. This was a great event, and we are very close to the keynote. Andra, would you like to add something?
Yeah, sure. I would like to add more thanks because it's the end of track 2, and I don't want us to leave without saying thank you to AWS and HashiCorp for sponsoring. Also to the amazing Western Interpreting Network Institute for helping us out with the amazing interpreters we had on today for every track. Also, you don't know this, but behind all of the streams, it's an amazing person who takes care of everything running smoothly. The live stream goes well technically. That's Torsten. Thank you, Torsten, for helping us from the shadows. It really makes a difference. And yeah, thanks everybody for being here, for contributing, and looking forward to seeing you all again next year. And don't forget about the keynote.
Yeah, exactly. Keynote is starting in 7 minutes on the track 1, as Andra said. So we are having an interesting session about contributing to CDK. So hopefully you will be still with us and you will join us on the track 1. Thank you, Andra, for co-hosting. Thank you, Satya. Thank you, Ben, for being with us today. And thank you, all of you who watched us and contributed to this event.
Yeah, thank you. Bye.
Cheers. Goodbye.